Hey, this is Rez. I run voxai.com, where we teach VFX through online courses, primarily focusing on Houdini and Nuke. I've been using Nuke professionally in my work for several years now, and it's been a crucial component in all of my projects. I truly believe that only through Nuke you can push your renders a step above and really unlock your potential as a 3D artist. Every compositor knows that some things are faster and easier to do in comp rather than in 3D. So with Nuke, we not only have the power to dramatically change the renders, but we can also increase the speed of our final output by understanding where we can skip certain steps in 3D and do them directly in comp. And so learning and understanding compositing will really provide you with the best results in the long term. I've designed this course in a follow-along manner, so my recommendation will be to go through this course once only by watching the lessons, and then run the course again one more time and also follow along with the lessons. In the case for Nuke, there's really not so much technical understanding around it as, let's say, Houdini. So really the best way to learn Nuke will be by actually using it. All the renders and assets needed to follow along will be provided, so simply follow the link in the description of the lesson to download these renders. And with that being said, let's get started with Intro to Nuke for 3D artists. Before we get started on the actual project that we're gonna work on, we first have to cover a little bit of some Nuke basics like hotkeys and interface, navigation, and so on. Just in case this is your first time using Nuke, I want to go over some of these settings real quick so we are on the same page, but ideally we would like to jump into the main project as soon as possible and get our hands dirty, because really that's the best way to learn. With that being said, when it comes to the main project, what I will recommend is that you first watch a lesson, then rewatch the lesson while following along, and then finally try to recreate everything yourself to solidify the information, and reference the course lessons only where you need. So with that in mind, let's go ahead and first we'll create a new comp over here, just so we start from scratch as I explain some of the basics. Now, first of all, we can see that as I open up Nuke, we are greeted with a different interface than what we had previously, and this is because I'm using a custom workspace that I created. So if we go over to workspace over here, we can see we have a few options to choose from, and by default we will want to work in the compositing space. So if I select this one, now we're starting to get the interface that we actually need. So there are basically three main windows that we are interested in the most, which will be the node graph, so where we place our nodes. For example, I can drop down a grid over here. We have our viewer where we preview everything we do, and then we have our properties tab over here on the right. When I select a node, all of the properties for the node will show up over here on the right. Now you can see right away that what I have is a little bit different, and what I did essentially, it's the same windows, but I just swapped them around a little bit so it's more comfortable for me. Essentially, I took the node graph and I placed it over here to the side, so I have the viewer in the middle. Also, the curve editor and the dope sheet, these two windows are also pretty important. These have to do with keyframes, which we'll take a look into a little bit later. So I also dragged these ones over here as well with the node graph and the sequence we don't really need, so I just close this one, and now I can just close this entire, I think this is called a pane, so I can close this pane, and I essentially have the workspace that I'm usually using. So I save this as a workspace over here called nodes. This is how I usually start my projects. I open up a new comp and then I select the nodes preset for the workspace, and we're good to go. So again, we are in the node graph. We can drop down any node if we press tab, so I can drop down a saturation node if I want. We can see the properties on the right. We can also choose nodes from over here from this window. So for example, we have them grouped per what we're trying to achieve. So if we are working with 3D nodes, we have a 3D node group over here, so I can select this. Let's go to 3D classic. I can drop down a light, so we have this over here, but 99% of cases I'm just gonna go tab, select light, and then just drop this like so, through the tab menu. So we have this on the left over here. Sometimes it's useful if you don't really remember the name of the node. You might want to go, for example, in the 3D, let's say that I want to drop down a cube, but in Nuke it's called a box or whatever. You can find the name, you can look for it in these groups. But again, most of the time you're just gonna hit tab and then just type the first few letters of the node that you want, and you're going to drop it. So let's go ahead, get rid of these, and let's drop down again a grid. And to preview a node, all we have to do is select the node, and we can either hit any number from 1 to 0, so 1 2 3 4 5 all the way up to 0 on the keyboard. So if I select the grid and I press 1, we can see the preview for this grid in our viewer. So this is how we can preview our results. And what's really cool about this, if for example I drop down a ramp, I can preview the ramp with 2, and then I can reference the grid again with 1. We can see we have our 1 input connected over here to our viewer pointing to our grid, and our ramp is input 2. So I can add another one. I can do, let's do whatever, let's do a crop. I can set this to 3, and then I can switch between these 3 using the numbers. So this is really cool. This is right away a huge advantage over After Effects. I've been in After Effects for over 10 years, and it was always annoying whenever you wanted to preview a change. You would have to go and select the layer, toggle the visibility for that layer, or toggle the visibility for the effect to preview with and without. It was really annoying. I'm not sure the latest versions of After Effects, maybe there's some sort of plugin, or they finally implemented hotkeys for this. But just being able to preview the nodes like this is really helpful. We'll cover more about hotkeys as we go, but basically this is how you will navigate through your scene. So for example, in our main project file over here, if I want to preview a certain layer that we're working on, for example, this glow bounce layer, I can go ahead and I can go to the Premult result and press 1 to preview this. Or if I want to just preview the GI bounce or whatever, I can just preview my layer and I can do any adjustments on it. And I can, let's say for example, I want to add a grade. So I press the G to add a grade node, and I can increase the gain here to adjust the values. And now I can go to the end of my comp here to our final node, and usually I like to preview this with 5, and I can always reference the final effect with 5. You can obviously choose any number that you want, but now I can go back with 1 and just isolate this layer, and with 5 again I will go back to my final result, and I can adjust the grade and either look through the final result over here, so I can lower this grade adjustment, or I can just isolate this so I can see exactly what I'm doing, and at any time I will press 5 and I can preview the result also in the final comp as well. Really helpful. And this workflow is just something that you'll get used to the more you keep doing it. So 1 all the way up to 0, you're going to preview any node that you want. We have our node graph viewer and properties, and on the properties tab, the default here, we can see that there's a value of 1 here. The default here is 10, meaning that with this value set to 10, we can preview the properties for the last 10 selected nodes at the same time. So I have the properties for the crop node, and now if I double click the ramp to select it, we can also see the ramp properties stacked on top of the crop node properties. And as well, if I select the grid now with double click, I can see the grid properties stacked up. So we can stack up all the way to 10 different nodes, and we can clear these windows if I just close them. But really my preferred way of working, and maybe this is a Houdini thing, I usually want to preview the properties of just one node, the current node that I'm working on. So I set this property value here to 1, meaning that if I select the crop, I just have the crop properties and then the ramp, grid and so on, so I don't have them stacked. Sometimes you will need to see the properties of more than one node at the same time. So I might want to, if I set this to 5 for example, I might want to reference some of the values from the grid into the values of the ramp. I might want to link them up with expressions. In this case, it will be useful to have both of them open at the same time, but 90% of cases I just want to work on one single node, so I will set this to 1. And this is all just to mention that you will probably have this value at 10, and it's going to be entirely your call how many nodes you want to see at the same time. Now, Obviously, we have a bunch of buttons over here. We have our channels, or rather our layers, and to the left we have our channels. We'll look into these as we go. And one final thing before we get started is going to be the project settings tabs. So if I go in the node graph window over here and I click on an empty space to deselect any node and I press S, we can go to the properties tab over here. And really important is going to be the name and the project directory. I don't usually use these, even though I should. So if you set a name and a project directory over here, you will be able to reference the paths with an expression. I think it's root.folder or something like that, but don't really worry about this too much for now. What's going to be really important is going to be setting the frame range. So in our case, for the project we're going to work on, our renders go from 1001, and so this will be the start frame, and our end frame will be 1240. FPS will be 24. Again, this depends on the render, but usually it's either going to be 24 or 30. And for the size format, this will be really important as well to set this to the correct format right from the start. For example, if I leave this at the format that it currently has, which is this 2K Super 35 whatever format, if I drop down a radial, we can see this is nicely in the center of our comp. And if, for example, I deselect the radial, I press S to go back to the project settings and I switch the format over here, let's do maybe something way different like 8K, we can see now that the radial is no longer in the center of our screen. It's going to maintain the bounds it originally had. We can see if we draw an imaginary rectangle over here that was that original 2K format that we had, it's going to be in the center of this. So it got displaced when our format changed. And this will be the same for a lot of different nodes. So it happened to me a few times where I was working in a lower size format. For example, I was working on some proxy renders, which were 960 by 540, and I was using that format. And then when I switched to the high quality renders and I switched to the HD 1080 format, all of my radials and my masks and rotos got displaced and I had to manually readjust them. So it's really important that you work with the correct format right from the start. And again, now that I have this HD 1080, which is the format that we need for our renders, so we can keep this format. Now we can see that this original radial that I dropped again is not centered, but if I drop down a new radial, it's going to be nicely in the center of our screen. So this will be about the format, and finally we can talk about the color as well. The default color management here, I believe maybe it's set to Nuke, but for our renders, which are rendered in ACES, we have to set the color management here to OCIO, and you should have in the OCIO config, you should have an ACES option over here, and then here we can select ACES 1.2, and then this will set all of our other settings to their correct inputs. And we are pretty much good to go. These will be the project settings that we need, and these are some of the basics, and really a lot of this stuff will make more sense as we go, and with the next lessons we can start working on our project. So I'm gonna go ahead and delete all of these nodes. We have all of the project settings that we need. I will let's go ahead and save this. So I'll press Ctrl S. You can give this any name that you want, hit save, and with the next lesson we can bring in our renders and start working. The best way to learn Houdini and Nuke is through project-based courses. All of our courses on Voxside are based on real-world projects created for various clients like Riot Games, Puma, and many more. So if you want to see how Houdini and Nuke is used in production, you can check out the courses on voxside.com. So we are ready to start. Let's go ahead and bring in some renders. So to start any kind of composition, we'll have to read in our files. And while I'm in the node graph window, we can press R. So this is essentially, we can also hit tab and place down a read node like this. So I will select read from here, press enter, and then this will prompt a window for us where we can select our file. So I'll go up, and here are essentially the folders with containing all of the renders that you've been provided with in the downloads. And if I click in any of these folders, let's start with the hero environment 01. I'll click this folder. Here we can see that we have a sequence. So notice where it says here, so it says intro nuke 02, hero environment 01, and then a bunch of hashtags. These hashtags will represent the actual frame that we are going to read. So if we were to look at this folder in our file explorer, this looks something like this. So it's a bunch of files here, each corresponding for each individual frame. So you will be more than used to this. If you've ever created a render sequence from a 3D application, you will most likely know that the preferred way of working is by rendering out and exporting each individual frame rather than exporting an entire sequence with all of the frames packed into like a .mov file or something like that. You will definitely work with image sequences, and in this case it's going to be an EXR sequence. We're going to talk more about EXRs in a second. And also to note here is that if I just want to import one single frame, I don't want to bring this in as a sequence, we have an option over here. So if I disable sequences, then we can bring in just an individual frame. But usually you will want to bring in the entire sequence. So I can double click to read in our sequence, and then we can see our read node over here. It has a nice thumbnail of our render, and if I connect this to our viewer by pressing 1, we can now see this in the viewer here, and I can go to the beginning of the timeline, I can press play. Now we can see that this is our current render. You will also notice here, as our animation plays, we are loading up this orange bar here at the bottom. This orange bar essentially means that we are storing the results, we are caching the results on our drive, and now we are playing this back in real time. But for example, if we had later, when we have a lot more nodes, this will start to slow down a little bit, so the caching portion essentially. But once this timeline is cached out, so we have this full orange bar, then we are going to be able to preview in real time our results. I can also zoom in on this timeline if I hold right click and I drag it over a region. Now when I release right click, we are going to zoom in on our selected frames, and now when I play the animation, it's going to loop only that specific region. So if I just want to work on an isolated part of the render, then I can do this, and to go back to the full range that we set in our project settings, we can just right click on the timeline and it will select the entire range. On the note for timeline and caching, if I press spacebar, we can zoom in on our render, or rather the window. So if I do spacebar again and I'm hovering over the node graph, we can also zoom in on our node graph as well, and this will work with any window. But specifically this is useful for the viewer. So if I press spacebar here, we can zoom in on our render and we can look closer and inspect our results. And now you might have noticed that our cached timeline disappeared, and only this region is now cached out. And this happens when you are zooming either in or out. We can see that as I zoom back out, we get our cached timeline back, but when I zoom in, so maybe if I zoom in even further, we no longer have this. And this is because Nuke will cache by default at sort of the level of zoom that we have. So if I press spacebar again, and we can also press F to frame in on our render like so, or we can press H and it will try to fit with the bounds of the window, but generally I like to use F. So for example, here we are a little bit zoomed out of our render, and Nuke will try to cache at this size, and this is why when we zoom in we lose some of that cache, because essentially now we are sort of at a higher resolution. But if we want to have consistent caching, we can turn on this option here where it says full frame processing. And by the way, we can see that as I hover over any of these icons, we have a nice tooltip which tells us exactly what the buttons do. So this is very, very helpful. We can pretty much hover over any property in any node, and we can get a quick description of what that property does. So this is really, really handy. But now essentially if I turn on full frame processing, this means that now Nuke will always render at the highest quality. So now if I do a cache, let's maybe just zoom in on a smaller region over here, I'll press play so I can cache this. We can see that no matter at what level I zoom in, the cache will remain. So this is very helpful. I don't really have this setting turned on by default, maybe at a later stage in the project I will turn this on, but still it's a very important option to note. So we have our environment render, and let's right away start to have a little bit of fun and start actually compositing. Let's say that I want to add a background to this city, so I will just simply drop down a ramp, and this isn't what we're gonna do for the final project, but this is just to demonstrate. Let's preview the ramp again by pressing 1. This will hook it up to our viewer. I will grab our handles here, so depending on what kind of node you're using, you might have some handles in the viewer. In this case, for the ramp, we can decide where our ramp will be by adjusting these 2 points. So let's maybe undo this, and I will grab the point at the bottom here. I will hold down shift and I will drag it up at the top, so we have this bottom to top white to black gradient like so. And now I want to place this behind our environment render. So we have our render over here and we have our ramp to the right, so I can set the ramp maybe to 2 on my keyboard, so I can cycle between these. So the way we now combine these renders is I can drop down a merge with M. I will also, if you do tab, you can also drop a merge from here, but since you will be using this merge all the time, it's really worth memorizing the shortcut for this, which is M. We see this merge expects 2 inputs, and what we want to do in this case is going to be what's called an A over B operation, where A is our foreground layer and B is our background layer. So this is how I like to remember which input is what. We can think of the B layer over here that stands for background. It's not really the technical definition, but this is just how I like to remember the order of layers. So our background in this case is going to be our ramp, and our foreground is going to be the environment. And now if I preview the result of this merge with 1, we can see our ramp behind our city. So we can also preview this animation now, and everything seems to work. Now the reason this works, if we look in our environment render, the reason this operation worked is because this layer has an alpha channel. So if I select this layer and while previewing this layer I press A over our viewer, we can see this black and white mask that determines what parts of our render will be seen and what parts will be transparent. So our black part is essentially what's going to be replaced by our B layer. Let's say that the ramp in this case is going to be our sky. So wherever we have black, it's going to be the sky. And then the white is going to be our render. So this is how this merge operation knows how to combine these 2 layers to obtain the result that we are after. And there are many different operations in merge. By default, when you drop down a merge node, it's going to come with this over operation. But here we can see that we really have a lot of different operations. So we're gonna go over some of these a little bit more in depth later. And also, if you hover over this property over here, we can also see the math behind how these are calculated. And if you look in this list, you can find over more towards the end here. We can see that it's A plus B and in parentheses 1 minus small case a. Now, don't worry about this for now. A lot of these operations really are going to be done intuitively. So after you get used to compositing in Nuke, a lot of this will just be second nature, and you'll know which operations you'll want without really knowing the math behind them. So really, if I were to tell you without looking at this list how the out operation works, for example, I wouldn't be able to tell you the math, but I know what to expect from it when I use it. So that's what I mean by instinctively. And this is also why I would encourage you to just get your hands dirty as soon as possible and try some of these operations out yourself. There's also a cool property here in this merge node with the mix value. So let's get rid of this one and go back to our merge operation here. We can also determine how much strength we want from our A layer in this case. So if I were to set this to a lower value, we can see how we start to get more of our ramp and less of our geometries. And this mix property will be present on a lot of nodes as well. So if I drop down a grade node with G, we also have this mix node. And speaking of grade, let's go ahead and again, the shortcut for the grade node is G, and this is also one of the most common nodes you are going to use, so it's worth knowing this shortcut. If I were to drop now a grade after our our ramp and before our merge, I can go ahead and gain this down so I can darken our sky, and I can stack multiple grade nodes. I can do another grade node with G, and let's say that I want to make the sky more blue. I will go again to the gain node. We can also affect the gamma in this case, but for the gain node, let's click on this color wheels so we have access to the individual channels, and I will just bump up the blue channel and maybe decrease the red channel, so now our sky is blue. And again, maybe if this is too blue, I want to bring back more of my original ramp. I could use this mix value. Sometimes I do this. I will just lower this mix value, which essentially determines the strength of this gray node over here. So I can just lower this. Maybe I want 50% of this gray node to affect our render, so I will just set the mix value here to 0.5. So sometimes it's pretty useful. So let's bring in our character as well. I'll press R again. I'll go up. Let's bring in our hero character. I will double click on our render and we can preview this with 1. And with this layer selected, I will press M. And this will automatically connect it to our merge node as the foreground layer. So now our background layer, in this case, I want it to be both our sky and our city render. So I will point this B layer to our other merge. And now slowly we are starting to build our comp. And now, for example, I can grab this character layer over here. I will press G. I might want to darken this for whatever reason. Let's drop down the gain, and for our environment render as well, let's go ahead do another grade with G. Let's maybe gain this down as well. We can lower the gamma, and this right here, what we've done so far is a very basic comp, but this is essentially the workflow. From here, it's just a matter of adding more stuff and creating our own layers that we will merge in with the rest of our composition. But this is really the general workflow. And in my case, and what makes sense to me with any kind of comp, is to work from the furthest element back to the element that's closest to the camera, so that's in front. So in this case, we have our sky. This will be our furthest element away from the camera. Then on top of that, we have our environment, and on top of this, we add our character. And now we have, like I've shown you earlier, we have complete control over each individual layer. Now with the next lesson, we'll go more in depth about how we can get the ultimate control with render passes, but this essentially is a very basic composition. So I would like you to try this out yourself with just these 2 nodes for now, or rather 3 nodes, including the read node. So get familiar with the read node and especially the merge and the grade node. Try out to build this very basic composition, and with the next lesson we'll take a look into how we can get even more control and start to take a deeper dive into compositing. So earlier we've mentioned that our sequence is an EXR sequence, as we can see here, .exr, and there's basically 2 big distinctions when it comes to EXRs as opposed to other image formats like JPEG or PNGs. So first of all, with EXRs, we can store from the render pixel values that are over 1. So if we look at our character render, we can see that some of the different parts of the character will have different values. So for example, if I look at the sword, the specularity will have pixel values that go over 1. We can check our pixel information over here at the bottom. As I hover over this sword over here, I can even sample a region. If I hold down Control and Shift and draw a rectangle, we can see that the average for this region is going to be this 4.9 value on all of our channels, so RGB channels. And then over here we have normal values, so under 1, 0.39 and so on. But the important thing to note here is storing this value that is over 1, because if I drop down a grade node and I gain this down, we can also check this. Let's maybe get rid of this grade node, and we can also use our gain and gamma sliders over here in the viewer. So the difference here is that when we do this, we can see that we can gain our image down. When we do this in the viewer, this isn't really applying it to our render, and we can always just get it back if we click where it says this f divided by 20 property over here to reset it to the defaults. So these sliders here are really just to troubleshoot for different areas without having to add a gain node and actually affecting the comp. We can just inspect our renders here and then we can reset them by clicking on this F thing here and this Y thing for the gamma. So as we gain this down, we can see that we actually preserve some of the detail in the texture, and maybe this is more noticeable here. So if I reset this area over here, let's go ahead and sample this. So this is roughly 6.6, and if we were to gain this down, we can see that we will preserve all of this detail that's in the texture, so all of the scratches and all this nice detail. So a JPEG is different in this sense. JPEG has all of the values clamped to 1. So for example, I could drop down a clamp and let's connect this to our render. So when we preview this, already we can see something different. All of these pixel values now can't go really above 1. And if I were to do a gray node or actually change the f-stop here, when I gain this down, we can see we have this flat color. So we no longer have any of our details. So this is how a JPEG would work. And this is why these values that go above 1 is important. So when we go back to our actual render, we can see that we can see a huge difference between this. So this is one of the reasons why EXRs are powerful. And the other, even more powerful reason is the ability to store different render passes. So most of you watching this are probably familiar with Houdini. This is a Houdini channel primarily. So I will just step over in Houdini real quick to show you how I set up the render passes. So if I do a quick test render here in the viewport, we'll go to our camera. This is actually what we've exported in the render. And over here we have, this is the Karma render settings node. So this is Solaris. And by the way, if you're unfamiliar with Houdini, definitely check out voxsite.com, where we have a lot of free beginner classes for Houdini. So, but to keep things short and relevant to what we need, here in this tab, we have AOVs. So you will either hear the term AOV or render pass, and this essentially means that we can split up the render in each different contributions, so we can have the specularity different from the reflections, different from the diffuse passes, and so forth. And for example, here is where we can choose what AOVs we are exporting, so diffuse, reflections, and refractions. In this case, we don't have any refractions. We can choose lights and emissions. If we had volume, so we can render different effects separately. SSS stands for subsurface scattering. So if we had a character with skin, usually skin shaders have this SSS property, but in our case, we don't have this. Again, this is just to demonstrate. And then we have a lot of utility layers. We can export the position in world space. So this is stored again per pixel. Everything is stored per pixel. But if I go to this image planes over here, we can check out the individual render passes that we have or render AOVs. And also when we export the render from Houdini as an EXR and bring it over in Nuke, for example, our character render and also our environment render will both have the same AOVs, and we can check them. If we go where it says here RGBA, we can actually check our render passes. So we can go to the combine diffuse. We also have this separated per lights. So we have a distant light and a sky and a sun. So we can separate the contribution from the distant light, as we can see here. And again, it's useful to use these sliders here at the top to gain up, and some of these passes might come out really dark. So when you want to check if indeed there's something there, you can just use these sliders here. So we'll have our combined diffuse sky, sun. We have all of the contributions. So this combined glossy reflection, for example, is going to be all of the contributions for all of the lights put together, but we are going to separate them per light. So we have the distant one. Let's maybe reset this. So we have the sky and the sun. So having access to all of these layers, when we separate them and put them back together, we are going to come with what's called the beauty, which is the render that contains all of the information, essentially the RGBA in this case. And one quick note about this RGBA here, we can see that we can also preview just the RGB, and when we have this selected to RGB and I press A over my viewport, I can see the alpha channel only if I set this to RGBA. So when I have this RGBA here, if I press A, we can see the alpha channel. So it happened a few times where I would want to preview the alpha channel for a layer and it wouldn't show me the alpha layer, and this is because this was set to RGB. So make sure that whenever you want to go back to the beauty or the default, you set this to RGBA. We can also see that we can just preview the alpha, but this isn't really useful because we have the alpha information here by pressing A on the viewport. So when we bring in an EXR, like we have in this case, by default, it will show us the beauty. And in order to be able to individually affect all of the different render AOVs, we have to split them all up and then put them back together, and this splitting and putting back together of the AOVs is what's called recreating the beauty. So this will be our next step here. We can maybe start with the environment. I'm going to just go ahead and let's Control C, and I will Control V to paste this hero environment render over here and start a new comp maybe on the right. So earlier when I've shown you how we can preview the individual render passes through our viewer here, this isn't really splitting up our beauty. This is really just allowing us to preview the respective render AOV. So if we want to export this render, we would still export the RGBA, which is this right here. So what we need to do is split up each individual layer, and it would be kind of intuitive if we had a node that says something like split AOV, but in this case, to split up the renders, we need a shuffle node. So let's go ahead and press tab and drop down a shuffle, and with the environment render selected, this will automatically append it, and we can see that this is by default placed in the B input. And now here to the right we have our options. So by default we can see that our input layer, which is our B layer, and this is just the default configuration. We can also shuffle in layers from a different render, but in this case what we want is to shuffle one of our existing layers from this environment render into the RGBA layer. So really, all of this is to say that over here we can just select the AOV that we want to expose, and let's say that we want to start with the combined diffuse layer. So we can either choose the combined diffuse without any underscore, but like I said, we would want to separate this per individual light, so we can start with the combined diffuse distant. And we can see now that all of the individual channels, the RGB of the combined diffuse layer are going to be shuffled inside the RGB channels in the output layer. So from this shuffle now, this becomes our new RGB for this shuffle. And now we can do stuff with it. We can add a gray node, we can gain this up, and we can either press M to do a merge, and we can merge this on top of our original render. And if I set this operation to plus, we can go ahead and let's increase the gain here and maybe the gamma. We can see that we are adding another layer of our combined diffuse render pass on top of our beauty. This doesn't really make any sense, but the point is that after we do this shuffle, we can now start using this combined diffuse distant pass that we selected over here. So let's go ahead and get rid of this merge for now. And really what we have to do now, we can also get rid of the grade. So with the shuffle node, what we need to do is shuffle out all of the individual different render passes to recreate the beauty. And for example, if I want to duplicate this node, I can select this node, press Alt C. So Alt C will duplicate, and I can point this back to our render and this new shuffle. Let's go ahead and let's choose our combined diffuse emission. In this case, if we preview this, we can see that there isn't really anything here. So it happens occasionally, especially if we separate the lights per individual contribution, that some of these layers might come in empty. And let's just go to the next one, which will be our combined diffuse sky. So we can see that we do have some information over here. Let's go ahead and reset, and we can do, let's do one more for now. Let's do Alt C to duplicate the node, point this back to our render, and let's do our final combined diffuse, which will be the sun contribution. So we can preview this, and now if I go cycle through all of this, we can see each individual contribution for the combined diffuse split up per over its respective light. And now we can essentially start merging these. So I will select the first shuffle, I will press M, I can merge this with my second shuffle, and from this merge I can drop down another merge, and I can combine this with our third shuffle. And I will set this operation here to plus, and I will set also our second merge to plus. And now if we take a look at the result, this will be our combined diffuse, and I can start grading and doing stuff per individual pass. So I can add a grade node, and let's go to our shuffle. This will be our sky contribution. So if I preview the result from our last merge and go to this grade node that's affecting the sky, I can set the gain to, let's maybe go to 0. So now I don't have any contribution from the skylight, and hopefully you can see where I'm going with this. Now, something I like doing with the shuffle nodes, we can go to the node tab. We can see we have a tab for shuffle over here, and most nodes will also have this node tab over here where we can give this a label. So in the shuffle node, we can see that this is the combined diffuse distance. So we can go to the label here and we can specify ourselves what we are shuffling in. So this will be our, let's do diffuse distant, and now we will see this over here in our node graph, so we know which shuffle is which. But another thing that you can also do is we can grab the name that we shuffle in. So we can grab this input name here. If we do an expression, or rather a syntax, so we can do open brackets and we can type value, and we want to read this from the in1 parameter. So here we'll do in1 and we'll close brackets. So now this will give me the name over here, combined diffuse distance. And for example, if we select this one and change this to a different one, facing ratio, we can see now that this says facing ratio. So I will undo this. Let's bring back our combined diffuse, and we can go ahead and copy this value in one syntax over here to our other shuffles as well. Let's copy this to our third one, so we can easily differentiate between these, between all of these shuffles. Now we can organize these layers a little bit because we still have to bring in a lot of other render passes as well, so we don't really want to have a messy organization here. So what we can do, if I hold down Control, we can see that this now creates a dot at the center of each individual wire, and I can click while holding Control to add a dot, and I can rewire all of my nodes like this. So for example, now I can add another dot over here with Control, and I can maybe rewire my nodes like this. And this is how I like to organize my beauty recreation setup. I think this is the most intuitive way, at least for me. So I know all of these merge operations need to be plus. I can maybe add another dot over here so we can see how easily we can start to organize things. If I just want to add a dot anywhere in this space, I can press period on the keyboard, and we can see that this drops down a dot, and we can connect this anywhere. And we'll talk a little bit more about wire management as we start to add more nodes. So let's also get rid of this gray node for now, and let's bring in the rest of our AOVs. So we'll go ahead from here and bring in our remaining passes, and what I like to do is we can just grab a bunch of these nodes together, and I can press Alt-C to duplicate all of them. Then I will connect these two copies up, and so we are on our fourth shuffle now. Let's go ahead and we can bring in the combined glossy reflection, and again this is separated for the lights as well. So we are interested in the distant light, the sky, and the sun. So we'll grab the distant one, and for our next one, let's go ahead and we'll grab our sky. So again, this is the combined glossy reflection. Previously we had the combined diffuse, so we'll bring in the reflection sky, and we'll do one more. I'm going to grab a bunch of nodes and press Alt-C to duplicate. Let's hook up our sixth shuffle, and we'll shuffle in our reflection sky. So if we look at these as well, they look like this. So when we now add all of these together, I'm previewing the final result of our final merge node over here. If we compare it with our original render, I'll press 2 on the render. So now we can see I'm switching between this merge over here at the end and our render. So we can compare these two, and we have almost the same result. Something's missing over here. We can see if we check this first combined diffuse shuffle over here, we can see that the wires are actually disconnected. So if we want to connect all of of these wires up, so the RGB, we can just click drag on the input layer and drag it over the output layer, and now we have our pass back, and we can check our other ones as well. All of these are connected. So now if we preview again the final result from the merge and our original render, we can see we have the exact same result. Now, one thing I also like to do here is reverse the order of this merge operation. So currently the first input is A and the second input is B, and we can press Shift X with the node selected to reverse the order, and this works with merge but also works with other nodes as well. So it's a very useful shortcut to know. And the reason I want this B layer to be the first one and the A layer to be the second one, if I look at this merge result and press D, so D is another very important hotkey which we can use to disable layers. So for example, if on this merge I disable it, we see only the B layer, and then when I press D again to enable it, we have the contribution of our second shuffle. So I will press Shift X on all of our merge nodes over here, so it's going B to A. And now, for example, if I go to the beginning, let's maybe preview the result from our last merge node, and I would disable all of our merge nodes with D. Now I can enable them one by one and see exactly how everything adds up, create our final beauty. And this is very useful sometimes to troubleshoot things. Sometimes you don't know the contribution of a certain layer, so you can really troubleshoot easily if you just disable the layer. So now I can see that this reflection distant light over here is contributing to this part of our render. So this is really the setup for the beauty recreation. Now, how do we know that all of these passes have to be added together? So how do we know that this merge should be a plus operation and not something else? This has to do with the specific render engine that you're using. So this is the way it works with Karma from Houdini, but this would be pretty similar with other render engines as well. So in the past I've used Redshift, and most of the operations in Redshift are also a plus operation. For Redshift, for example, you can check out the documentation, and if we look, we can see here on the AOV documentation that the beauty, if I zoom in here, beauty equals, and here we have all of the different passes and how they should be put together. So we see that we plus the diffuse lighting with the global illumination, with the specular, everything is a plus. And then after you plus everything together, you multiply it by a volume tint. So again, all of these are just render AOVs or render passes. You multiply all of these with the volume tint, and then on top of that, you add the volume emission and volume lighting. Now, in our case, we don't actually have volumes in our render, but it would be the same pretty much for Karma as well. If you don't want to overcomplicate things in the beginning, just remember that most of these render passes should be plussed together. So then finally we have our beauty recreation setup here, and I can go, for example, to the reflection distant pass over here, drop a grade with G, and I can gain this down, so I can remove this if I don't want to. We can add another grade here for the sky contribution, and we can see how overall we're removing some of this reflection. Maybe we have too much reflection from the sun. I can gain this down. Maybe I want to bring in more contribution from the sky on the combined diffuse layer here, and I can bump this up, and we can see already if I look at the final result, and I like to preview my final result with 5, so I will set this to 5, and with 1 I can inspect the current node that I want to. So if I preview now our initial render with our comped version, we can already see a difference. So this is how we can start working with passes, and this is why EXRs are super powerful. Now we're barely just scratching the surface of what's possible with passes, and we'll look into more examples as we go. But this is essentially a very basic beauty recreation setup. I'll grab all of these gray nodes and get rid of them. So you might want to get used to this setup because you'll be doing this a lot in CG compositing. Now, before we actually start adjusting all of these passes and grade stuff, there's one more crucial step that we have to take into account, and we can look at this with the next lesson. Now, unfortunately, we can't just start grading right away. There's still one more step that we have to do first, and this has to do with unpremultiplying the layer. So what do I mean by this? Let's maybe just first go to our original example. So here we have the ramp, that's the background, and on top of this we bring over our environment. And for example, if I were to add a gray node here and I want to do, let's maybe gain this up. So we are not really getting that problem yet, but if I were to do some more extreme grading, so if I were to also start reducing the gamma, now we will start to see this very subtle dark edge around our building here, and this is what we want to avoid. So the reason that this is happening is because of anti-aliasing, and really the more extreme our grading becomes, the more noticeable this dark edge becomes. So this is really not what we want, and if we look at our render, we can see that this edge here around our building, this very subtle ramp, is what's causing this problem to happen. So by default, all of the render engines will have this sort of anti-aliasing in order to allow smooth edges so that everything blends a little bit better together. And if we look at the alpha information, essentially what's happening is we are having the RGB pixel values multiplied by this alpha value. So we can see here this very subtle gradient over a few pixels from a full value of 1 to a value of 0, and when we switch over, so if I press A again, this translates over to the edges as well. So when we do our grading and we multiply these values, we can see, if I compare the original render with the grade version, we can see essentially we kind of lose one row of pixels if we compare these two values. We had some color information here on this pixel, and when we do our grading, we lose that information. So what we have to do is somehow get rid of this anti-aliased effect, and we want our RGB values to sort of ignore this gradient created by the alpha. And this is what the unpremultiplication will do for us. So for this read node, I will drop down an unpremult node. Let's go ahead and drop this down. We can see now with this unpremult, we sort of flatten out this gradient. It's kind of working like an edge extend. And really what's happening, we can see this over here, it's dividing the RGB values by the alpha values, and as a result, we get rid of our anti-aliasing. And now when we do our grading, we can see that between these two results, we no longer lose any row of pixels. Now, the problem here is that when we look at our merge, we obviously get a problem where our building is now extended. So if I were to disable both the unpremult and the grade, we can see that our building is a lot thicker. So obviously we don't want this. We want to bring back the smoothness of the anti-aliasing that our alpha provided. So after the grade node, what we can do is premult, right? So this will do the reverse of what the unpremult does. So when we add our premult, now we will get our edges back, and as a result, we can see we have that very thin smooth ramp on our edges. So if I were to grab the unpremult and the premult with shift, we can disable both of these layers, and we can see now that this is the original result that we had with that annoying black edge around the building. And if I enable this, we get rid of it, and we are sort of safe to do our grading however we want, without worrying about having that nasty black edge problem occurring. So really what's happening, this unpremult and premult, is it's just a simple divide and multiply operation. If I were to, let's maybe grab our render, and I'm just going to shuffle real quick. Let's grab the alpha, which is essentially what's happening. So if I hold down and drag a wire from the alpha and hold down Alt, we can connect the alpha to all of our RGBA layers. So now we have this black and white image across all of our RG and B channels as well. So now if I add a merge node and I were to divide this, let's set the operation here to divide, and let's reverse the order with Shift X. So when you are doing divide or a minus operation, the order here matters, but when you are doing a plus or a multiply operation, the nodes can be in any order, but it does matter when you are doing divide and minus. So we can see now that with this divide operation, we get the exact same result that our Unpremult does. So this is really all it does. And then to get our edges back, we can drop down another merge, and we will want to multiply this with our shuffle with this black and white image with the values that we want. And then we can set this to multiply, and we get our edges back. And in between, we can do our grading, we can do our safe grading without worrying about this ruining our edges. So really, this is all the Unpremult and Premultiplication will do. Every time you have a layer, whether it's a render or footage with transparency, anything that has an alpha, you will need to do this Unpremult and Premult business. So it's really important that you are aware of this. This can really ruin renders, especially when you are separating a lot of passes over here. You can imagine that adding up all of these pixel values together, you can really mess up the edges of a render. Sometimes you don't have to do this. For example, if this maybe if this environment render was exported with the sky as well, so now we have the alpha transparency because we don't have any sky. But if this were exported with sky and this alpha information was a completely one color across the entire image, then you probably wouldn't have to do this. But in this case, since we do have to replace the sky and we have to add this environment render on top of another layer, then we do need this Unpremult and Premultiplication thing to do the proper grading. Now, when we are splitting up the renders, we will need to unpremultiply all of these different AOVs in order to do the proper grading. But the problem here is, for example, if I were to drop an Unpremult over the combined diffuse distance shuffle over here, we can see that this isn't working. I can gain this up a little bit. We can see that this Unpremult really does nothing for this layer. And this is because by default here in the combined diffuse channel, we are just bringing in the RGB channels from this combined diffuse distance pass and outputting them only to the RGB channel. So if I press A over this shuffle, we don't have any alpha information. So we also need to bring in for each shuffle our alpha information from the original render. So we can do this directly in this shuffle node. We have another layer over here. We can grab the alpha. So we'll grab the alpha, and this B layer is looking at our read node over here, which has our main render. So if I grab the alpha from this render and plug this in our output of this shuffle, now if I press A, we see we bring in the alpha. And if I go back to the Unpremult and let's zoom in here and I enable this, now we can see that our combined diffuse distance pass is unpremulted and we can do our grading. So we can drop down a grade from here. Let's reset the gain viewer over here so I can gain this up. I can do whatever adjustment and then I can do a premult to get back our edges. Now, another thing to note here, when you are splitting up the AOVs and doing this unpremultiplication thing, you do want the unpremult to affect each individual pass, but you don't want to do the premultiplication after each individual pass, because what happens is when we add our layers together, the pixel values change. So when we do this plus operation, our edges will change, and when we add another pass on top, our edges will change again. So what we want to do is do just one premultiplication at the end of all of our added shuffles. So I will get rid of this premultiplication now, and we want to do the premultiplication after our last merge node. So from over here, we want to do a premult. The problem what happens here again is that when we add all of these different shuffles together, our alpha, our final alpha from over here will change. So if I press A, we do have the alpha because we are bringing it over from our first shuffle. So we do have the correct alpha in this case. But if this second shuffle, we also will have to bring in the alpha as well. So we'll connect this here and we'll do an unpremult so we can prepare this for grading. So now, for example, if we look at the result, we have added both of these alphas together. So we essentially multiply the alpha by 2. And if we compare this with our original render, we can see that the alphas aren't matching. So what we need to do is, after we merge all of these shuffles together, all of our AOVs together, we need to bring in the original alpha from our main render. And we can do this with a copy node. So we can drop down a copy node, and also the hotkey for this will be K on your keyboard. So this will bring up a copy node. Let's go ahead, and we want to copy from A to B, and we can see that by default we can copy different channels, but by default this will copy the alpha to alpha, and we can see this over here. So we can also maybe copy other channels to other channels, but in 90% of cases this is really used to copy the alpha. We want to copy the alpha from our main render, and I will point this over at this dot over here, and let's maybe add another new dot. So if we follow the chain here for this A layer in the copy, we can see that this will point all the way back to our original render. So we'll grab the alpha from the render, and we want to copy it. This B layer should be our merged result. So from our main render to our final result here from the merge, if we look at this result now, we get the alpha that we need, and now we can do our premult after we get the alpha. And if I press A, now we have our anti-aliased edges back. We have that smooth fade over our edges, and we are free to do any grading adjustments that we want. We can gain this up, for example. And also very important, now that we have the proper alpha after this copy node, we can also, for example, let's go ahead and grab this ramp that we created earlier. I will press Alt-C to duplicate all of these nodes. So this is just our placeholder for the sky. But now that we have the proper alpha, we can drop down a merge, and we can merge our render on top. Of course, this has to be A over B. We want our background to be the sky. So I just reverse the nodes with Shift X, add another dot over here, preview the final result, and we can check to see if we get any weird issues on our edges. And in this case we do, because we have to unpremult all of these other shuffles as well. This is why we get this black edge still. Now we can either shuffle in the alpha individually for all of these other layers as well and then unpremult them, but we can also just run an unpremult over all of them at the same time. So let's go ahead and drop down another unpremult node. We will connect this here before we do our shuffle, and by default this will work only or on the RGB channels, but we can set this to work on all of the layers. So now if I set this to all, we can check, and we can see now that our combined diffuse, all of our passes are unpremulted, and we got rid of all the anti-aliased edges. And now essentially from our shuffle nodes we no longer need to bring in our alpha. I'll set this back to the first version that we had, so the default version, and let's go ahead and get rid of this alpha connection, and we no longer need to do our unpremult for each individual shuffles. Now sometimes usually I like to do unpremult per individual AOV, just because on the rare occasion I might not want some of the layers to be unpremulted. But to keep things simple, let's just run an unpremult application over all of these. So now finally, if I go at the end, let's set this back to RGBA. Now we can finally do our grading, so we can adjust all of these, and we will not have any problems with our edges. We can bump up the sun, and we can do some crazy stuff, and we can see that we have the correct smoothness over our edges. And this is now the final piece of the puzzle. Let's go ahead and get rid of the grade nodes. So we unpremult all of the shuffles, then we add them together. After we add them together, we copy back the original alpha from our render, and then we run a premult. And this is pretty much what you will have to do every time with renders. Now another problem that's happening when we run the unpremult operation over all of the channels, we have some utility layers over here. So for example, the position pass and maybe the normal pass as well. These layers, we might not want them to be unpremultiplied. We want to run them over the regular version without this premultiplication. So it will be more important down the line when we want to bring in these other layers, that we do a shuffle and we point them back to our original render without the premultiplication. So it's important that we don't connect the shuffle to our unpremult. So it's just something that you have to be aware of. And this is why sometimes I like to run an unpremult over each individual shuffle, just so I know exactly what's happening, and it's easier to keep track of the unpremult and premult stuff this way. But again, to keep things simple, we are just going to use this method where we unpremult all of them at the same time. And now with the next lesson, we can start grading and adjusting this environment a little bit. We can go ahead and let's start grading our environment, and we can just simply start and look at each individual layer. So for example, we can go to our diffuse distant light here and I can gain this up. I can either preview the results from all the way over here. Maybe for now I will just let's disconnect our ramp over here. We are going to replace this with an actual sky in a moment, but let's go ahead and we can grade this up or down. We can affect the contributions for each individual light, so I can start to really experiment. Now what I'm doing here is not really the proper way of working. You would have to adjust the lighting directly in 3D for the best results, because when we are adjusting this light in Nuke, we are kind of faking a lot of stuff. So really when we are lowering the diffuse contribution from the skylight, this would affect the reflection as well. So these would kind of go hand in hand, the reflections and the global illumination and all that stuff. And ideally you would get to as close as possible to the result that you are after directly in render. And I've chosen this render specifically to showcase more of an extreme example of how effective compositing can be, but ideally you would want to make a lot of these adjustments directly in render. Now, sometimes what I do is I get a very crude estimation of what I believe the final result should be. So when I'm look deving and experimenting, I might just throw a render like this with just some of the lights that I know I need, so an HDRI, a sunlight, a directional light, and so on. And I will just fine-tune them like this directly inside of Nuke, because really it's just faster to work like this, so we can see how easy this is. We don't have to really worry about anything 3D, so all of these changes I'm doing here are a lot faster than if we were to do them in 3D. So I can do some R&D and experiment with different kind of looks, and then I can go back in 3D and readjust my lights to match what I came up with in Nuke. Now, this kind of workflow is really only possible when you are doing both the 3D and the compositing, and 100% it's not something that's usually done in production. So usually you kind of want subtle changes only in compositing. You want to nail the result as much as possible directly in 3D. But again, when I work for myself and to showcase the power of compositing, I've chosen this extreme example. So we are going to do some very dramatic changes. Let's move forward now to our combined glossy reflection sky. We can also maybe lower this. I kind of like this reflection sky pass. I'll leave this rather unaltered, and let's add another gray node for our sun, and probably I will want to gain this down. I also want to get rid of a lot of this yellow tint that most of these sun layers will have. So for our combined glossy reflection sun, I can drop down a saturation, and I will just reduce the saturation. Probably I want to get rid of the yellows entirely, and so for the sun I will set the saturation to 0. If we go to our sky, I might want to keep some of this blue color that we are getting from the sky, and let's go to our distant light as well. This should be okay. This doesn't have any color. This is just a simple black and white layer, and let's move forward to our combined diffuse sun. Now really we should ideally use all of our passes to recreate the beauty, but in some cases you might not need some of these layers at all. So it happens often that I bypass some layers entirely. So for example, maybe I don't really need this distant light. We'll keep all of them for now, because we don't really know what we want until we add more layers on top. And really, let's for now just try to normalize the intensity and just try to flatten the colors a little bit. So we'll go to our sky. We might want to bump this up. Let's go to our reflection distant, and here I will drop this down quite a bit. Let's also look at our individual passes. So again, with 5, I will preview the end result. So number 5 is hooked up to this end merge node over here. So we'll go back to our sun shuffle here. Again, we will drop down a saturation and let's set this to 0. And with this grade node, let's preview the final result, and I can maybe lower this overall. And for our sky, combine diffuse sky, this should be fine. And finally, I might want to lower this as well. We can also maybe for this layer, let's preview the final result. Let's increase the gamma so we don't have this super sharp contrast for our distant light hitting the buildings here. And now we can lower this. So mainly here, I'm looking for luminance values. And this is just more of a personal thing, but I like to treat luminance values different from the color values. So in general, if you nail down the luminance, so sort of the intensity of the colors in your comp, it will look pretty good regardless of what colors you are using. So if the value of the color itself is good, then it will look good with any color, regardless if this is blue or yellow or whatever other color. Of course, we are still going to go for something pretty specific, but this is just to explain that what I'm trying to do right now is try to get the luminance values right. Now, it's also pretty hard to tell exactly what we need because we still need to add our character, and in between the character and the actual environment, we will bring in more elements and we'll create our own layers. So I won't spend that much time tweaking the values right now. I'm just trying to get in the ballpark, and then we'll add all of our other elements, and then we'll come back and readjust all of the values for our grade nodes and our saturation. And in this way, we will work non-destructively. And this is really the power of compositing and working in Nuke, that you can still come back to your very first layer and do some changes regardless of how many layers we are going to stack later below our first nodes over here. At this point, we can also bring in our character as well. Now, like I said, between the character and our environment, we have to add a lot of layers, but let's just go ahead and also recreate a simple beauty recreation just so we are used to this idea. And then with the next lesson, we can start working on our layers that are in between. So for now, I will just go ahead and I will copy this node. And again, you can just press R and you can read in the character render from over here so you can open it up. But in this case, I can just copy this because we already had this imported. So here is our character render. So again, we can just drop down a merge node from here, and this can go, so this will be the foreground now, and our background will be this merged result here, and we can see our character on top of our environment. And for this character, we can copy this exact same setup. If we look at this render, we will find, and here this really should have been set to RGBA, so we can also preview the alpha channel. So remember what I mentioned earlier was sometimes when you inspect these layers, you want to go back to RGBA and you select RGB as a mistake, and then you will no longer be able to preview the alpha channel. So that's a common mistake that might happen. And here we can see again that we will have all of our combined diffuse layers split by the same lights. And usually when you have a couple of objects that you want to render separately in a scene, you will want to render them in the same lighting conditions and export the same AOVs for them. But this is what usually happens. Now in reality, sometimes you might not have this luxury and you will have different lighting setups and also different AOVs, in which case your job as a compositor will be a little bit harder. But just to keep things simple for the sake of this course, I'm using the exact same lighting setup for both of these renders and the same AOVs, meaning that now, for example, I will disconnect our render for now. I can grab this entire setup with our Unpremult, all of our shuffles, and even all of our grading, and I will just copy and paste this over here, and now I can link up my render to this Unpremult, and essentially this will now do all of our operations that we did for our environment. These will now apply to our character. And let's also over here preview the RGB, or again, I selected RGB, but we should have selected RGBA. So right, so we also have the alpha, and now we can merge this on top of our environment render. And if we preview the final result, this is what we have. We can check our edges and see that everything matches. We don't have any weird black edges. Our unpremultiplication was correct. And also we transferred all of our, let's call this initial grading. So we've covered really a lot of steps so far. with just these techniques that we've covered so far, we can really push the renders pretty far. So we can see that if I were to look at my original result over here, let's maybe get rid of our grade nodes and just keep our essentially our our environment and our character. So if we look at this result and we look at our new result, we can already see a huge difference. And now we can come and, for example, for the character, let's say that I want to highlight more of the distant light. I can go here and I can increase the grade here, maybe reduce the gamma so I can push the color on this side of the character if I want. So we can treat them a little bit differently. And now, for example, if we want the character to pop out a little bit more, we can increase the contrast of the character with the background, and we'll look a little bit more into this later when we start to add more layers. But this right here is the very essence of CG compositing, this AOV splitting and then grading them per individual AOV, putting everything back together and then going back and readjusting different layers. And like I said, we are working non-destructively, meaning that at any point I can come back to our environment and I can bump this up if I want to in isolation of the character. And this is also something that's really hard to do. I mean, it's not really hard to do in CG, but for example, if I were to affect the light in my 3D scene, I would also bump the light for my character as well, unless I specifically tell the light to ignore certain objects in our scene. But obviously this is a lot more handy, and it's just quicker to do look dev, so I really prefer a lot of time to just do a lot of this lighting directly inside of Nuke. And like I mentioned, after I figure out what my light setup should be, I can come back in 3D and actually do them over there, if there's time, of course. So this is how we can use the AOVs when it comes to recreating the beauty pass and affecting each individual layer. But really, I'm just scratching the surface with AOVs. There's a lot of stuff that we can do. We can use some of the utility passes like the position and the normals to isolate certain parts of the renders. So in that sense, we can create new layers and new masks from these layers. And that's really when we unlock the power of compositing. So with the next lesson, we can take a look at how we can use some of these utility layers. So I will see you there. So we have all of the AOVs that contribute to recreating the beauty, which are these combined diffuse and reflection. So the diffuse, reflection, GI, all of these, everything that you use to recreate the beauty are essentially the layers that we need to rebuild the beauty. But then we can export a few extra layers that don't directly contribute to rebuilding the beauty, but are still essential in CG compositing. And I just want to give you an example in this lesson with one of these utility layers. So you don't have to follow along. This won't really be part of the main project, so to say, but let's go ahead and let's just copy one of these shuffle nodes, and I'm just going to paste this over here. And the reason that I'm copying the shuffle nodes is because we have this value in one expression set up for us. So if I were to connect this back to our render, let's go ahead, and one of these utility layers will be the normal pass. So we can grab the normal, and I will link all of the X, Y, and Z values here to our RG and B channels. And we can simply do this by dragging over the input inside the output, and we can see that this will make the connections for us. And right away, this is a weird looking pass. You might imagine that there's no way that we can use this in our comp. So if I were to just simply add this on our comp, it would make no sense. But what this normal pass is, we output the normal vector values as RGB values. So we can see here, if I were to isolate this part here, if I were to draw a sample region, we have negative 0.01 on our red channel, roughly 1 on our green channel, and then again roughly 0 on our blue channels. So we can imagine that the RGB channels in this case are going to be our X, Y, and Z values for this specific pixel. So if I step over in Houdini real quick, this is our 3D scene. So we can take a look at our normals, and if we were to look closer, let's say that this vector over here, we can can look at our coordinate system over here, and we can see that for the most part, this specific vector is mostly facing the z direction. So this would mean that it has a value closer to 1 on the z-axis, and then 0 on the x, and roughly 0 on the y, meaning that in 3D it will have a vector value of 0, 0, and 1 on x, y, and z. And this means that in Nuke, this will have, if we think of RGB values instead, this will have a 0, 0, and 1 value on RGB. So it will have 0 on the red, 0 on the green, and 1 on the blue. So it will be mostly blue. And this is in fact what we see over here. If we were to go to our building, we can see that this is mostly blue, and this is because this region of the geometry is mostly pointing in the z direction. And for our ground, for example, this is mostly pointing upwards, so this will be mostly green, which is a 0, 1, and 0 value in terms of RGB. So red, green, blue, green will have a value of 1, and this is why it's mostly green. Now, this is super helpful for us. We can do a lot with this normal AOV, but this is mainly used to relight scenes, and we can create special kind of masks with this layer. Now, we can create masks with any of the other layers as well, with the world position pass as well, and the depth AOV, and we'll take a look into this later. But specifically for our normal channel, if for example I want to isolate the part of our geometry that's facing upwards, so this is mostly going to be our ground, we can, let's first disconnect all of our values. So I just want to grab the y coordinate. I want to isolate the parts that are pointing upwards, and I will place this y channel in our alpha channel. So usually when you want to create a mask, you will be working with the alpha as an output, and I'll show you why in a second. But now if I were to press A, we can see that this is how our alpha channel looks right now. So we have isolated this region of our geometry. So now if I want, we can go to one of our combined, let's look for one of these shuffles here. We can go to our combined diffuse sun, and if I were to drop down a grade node, we can see that all of these color correction nodes, and a lot of these nodes will have an arrow to the right, and if I drag this over, we can see that it starts to say that this is used for masks. So we can point this arrow to our shuffle, and now with this gray node pointing the mask to the shuffle, if I turn up the gain, we can see that we are just affecting that part of our mask that we selected from our normal pass. And maybe we can make this even more obvious, so we can see that we are just affecting the part of the geometry essentially that's pointing upwards. So by default, the mask will look for our alpha channel. So here we can see we can turn on our mask. So if I were to not use any masks, we can see that our grade will affect all of our render. And when we turn on the mask, and the mask is turned on by default, we will look for the alpha channel of our input over here. And this is why I mentioned earlier that usually when you are creating a mask, you will work with the alpha channel. So now if I wanted to, I could go back to our shuffle here. I will press A, and I can append a grade node. I can further control this region that we selected over here. Now the grade node by default will work on the RGB channels. So in this case, we just want to operate over the alpha. So let's select the channels here to alpha. And if I squeeze in the gamma, if I lower the gamma, we can further isolate this region here. We can play around with the gain as well if we want. But in this case, since this is a mask, really our values shouldn't go over 1. So I would be a little bit more careful with the gain value here. But with this extra grade node on our alpha channel, which we get from our normal, if we go back to our grade over here, we have further refined our area, our mask selection. So if I were to disable and enable this, we can see that how easily we can just bump up the surface of our ground, for example, and we can see that this affects some of these surfaces over here as well. Now we can get rid of these surfaces if we want by by implementing even more utility layers to isolate certain parts. But this is just to give you an example of how we can use the utility layer. So this is one example where we are using it as a mask. And again, this isn't really what we are going to use in our final project. I'm just showing you this to demonstrate the power of utility nodes. So again, a utility node is something that doesn't contribute directly to recreating the beauty, but you can use it to create sort of kind of masks, and you can use them to map different kind of textures, and we'll see this in a second. And we can also use it to create new layers, which we will do in the next lesson. So with the next lesson, let's go ahead and get rid of this grade node and the shuffle. So with the next lesson, we'll take a look in how we can create a new layer with the utility passes. So I will see you there. Let's see how we can use the depth layer to create a new fog layer that we can place between our character and the environment. So let's go ahead, and we might make some room over here with our character shuffle AOV. So I'm just going to drag this entire setup down below, and we can start by grabbing one of our shuffle layers, and I will just copy one of these nodes and paste them down below. Again, we will want to grab one of these shuffles with our value in one expression here. And we'll need to point this shuffle back to our render, and we want to point this to our original render before our Unpremult node, and I'll explain why in a second. But essentially we want to bring in some layers that aren't affected by our premult now. So the layer that we will need will be this depth no AA. We have two versions of our depth layer. Let's first maybe look at our depth extra, and now here we have something new. We just have one input here. So essentially this depth layer is exporting just a float value. This depth layer essentially represents each individual pixel stores a value based on how far or close it is to our camera. So we don't want to create a mask. So if we wanted to create a mask using this layer, we would just plug this in our alpha and use the alpha as the mask. But in this case, we want to create a new layer that we can plus on top of our render. So in this case, I will hold down Alt while dragging this wire and connect this to all of our output layers. In this case, we just need the RGB, but we might as well keep the alpha here as well. We will replace the alpha in a second, so don't worry about this. But now if I were to preview this result, we have this what sort of looks like an alpha image. But if we hover over our pixels here, we can see how the values change here. So for example, if I were to select a region, if I were to sample a region that's closer to our camera, we have a value that's roughly 11. So because we are using the same value over here on all of our RG and B channels, we will have the same value on all of our channels. And we can see currently that this value is roughly 11. And if I were to sample a region that's farther away from the camera, so one of these buildings in the back, if I were to sample this region, we see now that this value is 422. So this is 422 units between this building as it exists in 3D space and our camera. And I can show you this because I have access to the 3D scene. If I were to step inside Houdini, we can see these are the buildings, and this is the building that's furthest away from our camera being right over here close to the origin of our world. Here we can see the camera. So if we were to draw a straight line between our camera that's over here, we were to draw a straight line to that sampled region that we have in Nuke, which is somewhere around on this building. This straight line, we can see our units represented over here on the X and the Z coordinates. So this straight line would be 422 units, and this is what this value here represents. Now currently this depth layer as it is, it's not really helpful for us because we see all of these values that go way beyond 1. So to normalize this value and actually see this distance on our buildings, we will have to use a gray node, and this is where our black point and our white point values over here become extremely useful. Because if I set this white point to be essentially, like I mentioned earlier, this is like a remapping operation, so I can set the highest value to be this 422 value. I will set the white point to be 422, press enter, and now we can see this nice smooth gradient growing across our our entire render, and the closest objects to our camera will have a lower value, and the furthest objects away from our camera will have a value close to 1. And now in fact we can see that our RGB values become this value of 1 because I set this over here. We can further control this value, and by the way, if you want to change the values in any of these properties, you can set the selection to either of these values, and I'm using the arrow keys left and right to go between these. So if I want to make smaller modifications, I will set the selector here between our second and third number, and I can just use my down and up arrow keys to increase the values. And if I want to make bigger changes, I can place the selector one value before, and I can make bigger changes like this. We can see how the values changes. You can also use the scroll wheel here. And if I want to make even bigger changes, I can set the selector to our first value, and I can use the up and down arrow keys or the scroll wheel, and we can see how fast we can adjust these values. So I might want to modify the second value here, and I can scroll up and down to further refine the gradient here and this remapping operation. So that's just a quick Nuke tip on how you can adjust the values. So now we have this new layer, and really, if we wanted, we could just merge it. So with this gray node selected, I pressed M, and this will drop down a merge node, and we can merge this on top of what we have. Now, in this case, we want to plus this on top, so we could use a plus operation, and now we can see a little bit of our render below. But sometimes when you want to add layers together, but you don't want really the pixel values to accumulate, you can use a screen operation instead. So this is what we'll do. Screen is like a clamped version of the plus. So again, when you want a more of a subtle, it's sort of like a soft plus operation, this screen thing over here. So it's another pretty common operation that you might want to use. Now, we're not getting exactly what we want. We do need to modify things a little bit. So this is our depth map, but we want to turn this into our fog layer. We don't really have a background for this, because essentially there were no objects in our 3D scene in order for us to record their distance information from the camera. So we will need to fill in our background ourselves. So we can create a constant, and the constant is like a fill color. It's just a flat solid color, and I will set the RGB values here. I will set this to 1, and now I can merge our depth layer on top. Let's connect these two layers, and I want our depth layer to be our foreground and our constant to be the background. So I will press Shift X to reverse this, and now we can see this really cool effect. So now it's actually starting to look more like a fog layer. And if we look at our final result as well, we can kind of start to see how things are lining up. Now, there's a few problems here to address, but the first thing that I want to address is if we look close enough, we can see this very harsh edge on our buildings, and this is coming from our fog layer that we just created. If I were to go to just the render, the composite version over here from our merge, we see we have these nice anti-aliased smooth edges on our building, and when we add our fog layer on top, we kind of have this harsh edge, sort of like the result that we get from the Unpremult operation that we do for the alpha. And this is because by default, most render engines, and specifically in Houdini, we render the depth without anti-aliasing, because this is what we need when we are doing bokeh or defocusing effects. So if we wanted to add depth of field to our render, we would need this version of the depth map without any filtering on our edges. And in Houdini, if I were to show this real quick, I will go over to Solaris, and here in our environment render settings, we can see here is where I selected all of the utility layers that we want to export, and we can see that this depth layer by default will use this pixel filter option over here, and we can see how this is set up. Essentially, it's kind of like unpremulting all of the edges, and we can see that the rest of these layers are using a different pixel filter. So this is the default filtering that provides the anti-aliasing and the smooth edges. So I've exported the depth as it is over here without the filtering, and then below I created another custom depth map, which is named depth no AA, and it's using the same filtering without anti-aliasing as the other ones as well. So if I go back inside of Nuke, here this depth underscore extra is the default one that Houdini provides, and I have added another one which is this depth no AA, and if I hook up all of these nodes to our RGB channels, we can see now we have a few issues here, but now we can see that we do have this filtering now on our edges. The new problem that's happening here is that we have to unpremult and then premult this around the alpha, so we can see that this problem is really just happening, this black edge is just happening around where we have our alpha. So we will need to bring in on our shuffle over here, we'll need to bring in the alpha that we had from our render, and because this B layer is pointing directly to our render, we can just grab the alpha from this B layer and we can output this on our output layer. So now if I press A, we have the correct alpha, and we can do an unpremult. Then we will run our grading, and then we can do a premult, and we'll have the correct edges when it comes to the alpha, but also the correct edges when it comes to the separation of objects inside this entire alpha space. So if I were to preview the result now, we no longer have any weird edges anywhere in our render. So while I'm recording this, I realize there's a lot of annoying stuff to do with these edges, with all this pixel filtering, with all this anti-aliasing, but really after a while this will just become second nature. I'm only realizing how annoying this can be as I'm explaining things, but when I'm actually comping myself and I'm just going full speed, I don't even realize just how annoying some of these edges can be. But sometimes they can be annoying if for some reason you just can't get the edges working right. There is also a dilate node which you can use. Actually, it's called erode. So if I drop down an erode node, now it says when you place this down, it says dilate, but you have to find it by typing erode. So it's a little bit weird. But this dilate, what this will do, it will just push out the pixels one row, so we can increase the size here, and and we can see what happens. We are just expanding the edges, and we can also contract the edges. So if for some reason at any point you end up with some weird edge issue that you can fix, you can always just place down an erode node, and you can either dial in maybe a value of 1 or 2 or increase the size to try to fix that problem. But in this case everything lines up, so I will get rid of this dilate, and we can come back to our final result over here. Now after this merge operation, I will want to drop down a grade node with G, and let's say that with this second grade node here, we can just control the overall strength of this fog layer. So I will just drop this down slightly. And one other thing that happens here, if I preview this from our merge, we can see that this building in the back is a little bit brighter than our background, so our constant, which doesn't really make sense because we want this constant to really be the brightest spot in our fog, because it's essentially the furthest thing away from our camera. So this is way out in Z space. So what we can do here after our grade node and before our premult, we can drop down a clamp as well, and this will make sure by default that no values will go above 1. So now when we add this together, we can see that this building here in the back completely fades off into the distance, and we can go back to our grade node and we can further control this. So maybe we want to reduce this a little bit, so I will just push the highest value, the white point, out a little bit further more, so I can increase the value here to roughly 500, and maybe this provides a better result. Again, we can preview this from our final result over here, and now with this grade node we can also control the gamma of this transition, so of this gradient in Z space. I can drop down the gammas to make this a little bit more obvious, and maybe actually I will want to lower the white point. I might want this building here in the back to be brighter a little bit, and we can already see with just this extra layer that we have instantly a lot of depth to our scene, and this really helps us to quickly see the space that we are in, and it creates this nice separation between our buildings. And we build this with just a few nodes directly inside of Nuke, which is really great. Let's maybe add another dot over here, and actually I will reroute this wire here for our shuffle. I'm just using control to add a few dot nodes, and maybe I'll drag all of this setup. I'm holding down shift to select extra nodes, and we can just drop this down below. And finally, one more thing that we can add here. So we have this gradient that's going across our Z space essentially, but we can also introduce a gradient that's going on the Y space, so vertical gradient. And we can do this very simply in this case by just using a ramp. I will throw down a ramp. Let's reverse the nodes over here. I'm holding down shift and I'm just trying to create this vertical ramp. So now we can just drop down a merge and we can multiply this over our result. So when we do this, we can see this is what we get, and we can very quickly bump up the detail even more. Let's maybe go to our gray node over here and just increase the gamma. So we push out our fog into the foreground more, and now we can preview our result, and this is it. So let's maybe this grade node I'll place below our ramp just so we have this sort of like global strength of our ramp. We can still play around with the gamma here as well, maybe lower the gain. Now we'll have to introduce our sky, so we will come back to this fog layer in a second, but this is more or less how you can very quickly, very easily set up a fog layer. From here we can control how further away in space we want this fog to be by playing around with our black and white points. So there's really a lot of stuff that you can do with this depth map, and like I said, usually it's used to create defocusing effects, but I really like to use it to isolate certain parts. So I like to use it in this case to create new layers like a fog layer. I like to use it to grade certain stuff. I usually like to darken stuff that's closer to the camera, and maybe we'll do this in a second as well. And with this vertical ramp, you always want to think of different ways in which you can break up your layers and add more detail and contrast to your layers. One more thing that we could do, and you don't have to follow along with this part, we could also break this up even more, and this is really how you should do fogs. You can add a noise, and we'll look more into noise a little bit later, but this is just a noise pattern essentially. We can also multiply our result with this noise, and now we can start to see, I'll add a gray node here and just gamma this up, and now we can really start to see some nice breakup, and this looks this works extremely well with fog layers like we have over here. The problem with this noise is that this is a 3D scene, so the camera is moving, so this noise pattern will not follow, and in this case we might have to create a 3D layer. So in our courses on voxite.com, in some of the courses we create this noise as a volume directly in 3D and export this and export it as a render, or in some courses we create this directly in Nuke with a particle system, just so this noise follows the camera and it's actually spread out in 3D space. So it doesn't work in this case with just this simple 2D noise layer, and I think for a beginner course it's not really worth going into particle systems and all of that right off the bat, so I don't want to really overload you with information, but just as an example, that's this is some of the stuff that you can do to create this breakup. You always want to think of how you can break up the layers even more and add more details. So this will be our fog for now. We can select all of the nodes that we have over here. Maybe we can select them with the dots, and if I do tab and drop down a backdrop, this will now create a backdrop for us. This is strictly for organizational purposes. We can spread this out a little bit. We can double click here inside the label, we can do fog, and I usually like to set these backdrops to be darker and more desaturated. So we have our fog layer here. We'll do a backdrop over our other setups as well for the environment and our character, but we'll have to add a few more stuff first. But for our fog, we are pretty much done. Like I mentioned earlier, we'll have to come back to this after we add our sky and some of the other elements. So with the next lesson, we can take care of our sky. So I will see you there. So we can use the AOVs to adjust our already existing render. We can use the utility passes to create our own layers, and we can also create layers by using Nuke's 3D system. And we're gonna do a brief introduction with Nuke's 3D system. It's if you're coming from a 3D application, this will be very familiar to you. Now, Nuke's 3D system isn't really as powerful as an actual 3D application, so you can't really model model things. You can adjust already existing models. You can do certain types of transform operations and soft transform, but really it's mostly here to help us place certain elements in our scene. And in this case, what we want to do next with this lesson is place a 3D sky that moves with the camera. So currently, if we were to bring in our sky, so I'm gonna press R and I'm gonna bring in an HDRI in this case. This would work with just a regular image of a sky. In this case, I'm using an HDRI, which we got from Polyhaven. So you will have the link if you want to use the same sky as me in the lesson description. Now with this, we can drop down a gray node and we can gain this down slightly, and we can't just really merge this behind our environment. So over here we have our environment. If I set the background to be our sky, first of all, we see we run into a problem where our resolutions no longer match. So our overcast sky over here, we can see we are using this resolution. So in this case, we would have to use a reformat node. And because we set our project settings, so when I press S without anything selected and go to our options over here, because we have set this to 1080p, our reformat by default will resize our footage or whatever we bring in to this 1920 by 1080. So now when we do our merge, this is going to work. Now if we just render a few frames over here, we are automatically going to see this problem that our geometry is moving. So our camera is moving, but our sky is static. So we need a sky to follow the camera. Now we are going to use the 3D system for this. Let's maybe just disconnect our sky, and I'll remove the reformat and the gray node and just keep the sky over here for now. While I'm over the viewport, if I press tab, this will now switch over to this 3D view, in which if I hold down Alt and left click, I can navigate around. I can hold down Alt and right click to zoom in, and Alt and middle click to pan things around. So it's really exactly like in most 3D applications. I believe somewhere in the project settings, let's go to edit, somewhere in the preferences over here, you can change how the navigation controls work if you are used to other hotkey combinations, but I'm just using Alt, left click, middle click and right click to zoom in, to move around and navigate in this 3D space. We have some options over here. We are not going to look into this right away. What I want to do is just give you a very brief introduction to how the system works. So let's say that we want to place a card in our scene, and we will do this in the next lesson. We are going to actually place our smoke cards, but right now let's just go ahead and place down a card. So you can see that in between brackets this says geometry. So this is what we want, and we can see this now in our 3D space. We can use a texture. So over here where it says image, we can append a texture, so we can point this to our sky, and now our sky will be mapped to our 2D card. We can also use any other image. We can also use our footage if we want. We can see now that the render is mapped to our card, or we can a lot of times you will have to use let's drop down a noise draw, so we can use a noise texture for our card. And now with our card selected, we see we have the gizmo here. We can use W, E and R to move, scale and rotate. So W, E, R, just like it would work in a 3D application. So we can push this further into Z space. We can scale this with R on individual axes, and we can rotate things around. And now if we wanted to use this in our comp, if I press tab again, we don't have anything showing, and this is because we have to render this from the 3D engine sort of to our actual comp, our 2D comp. So to do this, if I press tab again to go back to our view, we can drop down a scan line render, and over here we have two versions, and we are going to use the 3D classic. We are not going to use the beta versions for now. Let's just use the 3D classic versions of all of these 3D nodes. So let's drop down a scan line render, and here we have a background, an object or scene, and a camera. Now we don't have a background in this case, we don't need one, but our object in this case will be our card. So I'm going to move this over to the right, and by the way, if I hold down Control while I have a node selected, this will grab all of the nodes above it as well. So this works with any nodes. If I want to select this node over here, we can see all of the connections that we have with this node. So if I hold down Control while I'm dragging this around, it will grab the entirety of the nodes above it. So it's sometimes very useful for organization. Now we have our card. So if we go back to our scan line now, with just the card connected to our OBJ, if I press tab now, we actually see our card over here. By default, this will create a camera for us, even though we haven't specifically created the camera. It will create a camera for us that's right at the origin, and it's facing along the Z direction. So if I were to drop down a camera, again we will use the 3D classic version, we can see that this is the camera that we create. So we can now hook the cam arrow here to our camera, and if I go to our scan line and I press tab, we can now grab our camera, and inside the camera settings here we can use our translate, rotate and scale to move the camera around. So I can bring the camera back and we can press tab and see exactly what kind of transforms you are doing. We can use the gizmo as well. So I press W and we can grab the camera, rotate this around, and if I press tab, we can see how our render essentially changes. So we can adjust the camera through our settings here or directly in the 3D viewport. Now obviously in this case we are going to read in the camera that we export from our actual 3D scene. So we don't have to set the camera here. We can just select read from file and we are going to bring in this cam01 USD file. And now if I press tab, we can see our camera is all the way over here, and this will be placed exactly where it's placed in our 3D scene in Houdini as well. If I go back over here, we have our camera. We can see it's this camera here. And when I go over back inside of Nuke, it's again going to be over here. So now with this card selected, I can press W and I can push this around. I can bring this up, and I'm going to try to place this roughly somewhere where our camera can see it. I can increase the uniform scale here. And when we go back to our render, let's maybe just make this a little bit smaller. Now this will follow our camera. So essentially this is an element that we can now use in our composition. So from our scanline render, if we want, and this is something similar that we will do with the smoke cards later, we can just do a merge with M and just place this here on top of our render. Now currently this doesn't look like anything, but we can see that it's following the camera and it's nicely integrated with our 3D system. So let's get rid of this merge, and in the case for our sky, we don't press tab. We don't really want a card, although we could use a card and just push this back into 3D space like so and just make this bigger, sort of how we would do it in a regular 3D scene. But in this case, it's better off if we use a sphere instead. So we will drop down a sphere, and here we can see our sphere is really small, so we want this to be huge in order to encompass our entire geometry. So I'm going to push out the uniform scale by quite a lot. Let's try a value of 100, and now we can see our sphere and we can get rid of our card with the noise. And for the sphere, again, we can just map any texture that we want, and in this case we will map our sky HDRI, so we can point the image to our sky and we can see our sky nicely mapped to our sphere. Now this sky is 4K by 2K, so we don't really need to use this much resolution for the sky. In fact, I want to lower this by half. So if I drop down a reformat node after, by default this will look at our root format, which is 1920 by 1080 again. But in this case, I will just set this to scale, and I want to specify exactly how much I want to scale this. In this case, I will scale this down by 50%. So if I set the scale to 0.5, this will now give me a 2K by 1K value. So when we map this onto our sphere, because this is placed all the way in the back and we are covering a very small part of our screen and we have a bunch of elements on top, we don't really need that extra resolution from a 4K map, and this will just improve our performance a little bit. So now we can use this. We'll point the object scene from our scanline render to our sphere, and if I go to the scanline and preview this and hit tab, now we can see our sky will follow our camera. If I just load up a little bit of this animation, let's take a look. All right, so now we can use this layer here, the scanline render layer, as our background, and finally we have a sky in our render as well. And after the scan line, we can do any changes that we want. We can also do them directly on our texture as well. So either we add a gray node after the scan line and drop this down, maybe decrease the gamma a little bit, or I just do a gray node after our reformat. So before we map this texture onto our sphere, we can also affect the grading here. In this case, maybe we can just use the grading after the scan line. So I can drop this down slightly, and this is looking fairly decent. We can rotate the sphere if we want to get a different part of our sky onto our render. So if I go to the sphere here, I can choose the rotate Y value here. I can just use the scroll wheel. Maybe let's try to find a different part or rather area of our sky. So this is exactly how it would work if we were to use a HDRI inside 3D directly. But really in this case, I would use a 3D projection of the sky. Now I don't really want to get into 3D projection because it might be a little bit beyond a beginner course. I feel like a lot of these things that I've already covered are maybe slightly beyond an introduction course. So I want to avoid getting too deep into some of these techniques, but with a 3D projection, for example, in our Ultimate Effects workshop on voxsite.com, we used a 3D projection to manually place cloud lining textures between clouds to decide exactly where lining can happen in the sky. So you can get pretty advanced with some of the stuff that you can do with a 3D projection and with the 3D system in general. But to keep things simple, let's just keep this as it is right here. We are just using a texture, mapping it onto a sphere, and then bringing in the camera from our 3D scene. We have our sphere linked up to our scanline render, and then this is basically a very simple sky replacement technique. We should probably also preview this from our fog layer as well to better judge how our sky should look. So now I can go back to our grade. Maybe I can bring this up or down and I can play around with the rotation Y of our sphere, and I will leave this up to you. But one final thing that I would like to touch up on is if we go back to our 3D view and we hit tab, first of all, sometimes you might want to display multiple different settings here. So when I'm dealing with 3D, I will set this value to maybe 5, just because if I were to just have one over here like I usually do, and I would select the sphere and preview just the sphere, we can see that now this no longer shows us our camera. And now if I select the camera and preview the camera, we no longer see the sphere. So to fix this, we can set this to 5. And now if I were to select the sphere and preview the sphere, we also have the camera showing as well, because we have the settings of the camera opened over here to the right. So all of this to say is that sometimes if you have a hard time dealing with the geometry in this 3D system and you want your 3D geometry to show up at all times in this 3D view, just make sure that you are not using one over here as your displayed settings. And one more thing about this sphere technique to replace the sky, we don't really know exactly how big this sphere should be. This sphere should really be all the way in the back of our geometry. So at the very least, it should be way bigger than the building that's furthest away from our camera, but we don't really know where that building would line up in 3D space. And this is where we have a node that's called position to points. So if we hook this up to our main render over here, I'm just going to use this dot from over here that essentially points to our, in this case we can look at our unpremulted layer, doesn't really matter, or let's just maybe point this to our render for simplicity's sake. So this position to points node is pointing to our render, and inside here, let's set this back to, or actually let's just keep this at 5 because we are dealing with the 3D system. We can set this surface point we will set this to look at our world position, which is going to be this P layer. And now when we do this, let's go ahead and just preview this layer. So in this case, I'm going to go ahead and set this only to 1 because I just want to focus on this single layer. So in some cases, it's actually better if you just set this to 1 because you want to isolate your 3D object that you're working on. Anyway, our position to points, this is a really cool representation in 3D space of our render scene. Basically, what this does is it's spreading out all of our pixels from our main beauty render, so from the RGB channels. It's arranging the pixels based on their world position value. So if we were to press tab and just look at our world position, so I'm going to look at our render and set this to our P value, we can see that as I hover over the pixels here, if I just sample this region, we can see that this surface of the building has a coordinate of 52 on the X, 17 on the Y, and -73 on the Z. So this is how our position to points knows where to place our pixels in the 3D space. So if I go back to the position to points, we get this really cool representation here, and it's super useful to troubleshoot your 3D objects and to know where you should place, because now if I set these properties here, let's increase this to 5 so we can also see our sphere. If I also select our sphere, we can see that it's actually not entirely covering up our geometry. So like I mentioned earlier, this sphere should be at least as big as our furthest away point in our geometry, so it should be way beyond this building here in the back. So now that I have this 3D representation, I can simply increase the uniform scale as much as I need to. So I will set this to maybe 1000 just to make sure that this is big enough. So if I preview this now in 3D, we can see that this is more or less where we should place the sky in relation to our building. So now when we go over to our merge result over here, let's set this back to RGBA and Control Shift click to get rid of that sample region. Now we will know for sure that the movement of the sky is correctly matching the movement of our 3D scene, because for example, if so currently our sphere is set to 1000. If I were to set this back to 100, we can see this changes a little bit, and this will mean that our sky is going to move way too much in relation with our geometry, and it really won't feel when you preview this animation. Let's maybe just render a few frames. It really won't feel like this sky is way beyond our geometry, so pushed in Z space. I'm not sure how noticeable this will be, but we can kind of feel it that the sky is a little bit flat. There's really no parallax happening here, and if I set this uniform scale back to 1000, this will now, our sky should move a little bit slower than our geometry. Again, I'm not really sure how noticeable this is. It's probably not that noticeable, but this sort of thing is really important, especially with the next lesson when we look into setting up our 2D cards for the smoke. This will be extremely crucial that we place them in the 3D world exactly where they should be in order to do the proper compositing. So for now, at least, we are pretty much done with the sky. We are going to leave this position to points over here because we'll need this in the next lesson. But for now, let's go ahead and just grab all of these nodes, drop down a backdrop, and let's go ahead, rename this label here to sky, and also just darken this a little bit. So this will be our simple sky setup. Again, we might want to preview this from our result with the fog as well. And if we compare the renders, again, we are really starting to see a big difference. So with the next lesson, let's take a look into how we can add our smoke cards. So I will see you there. Now that we are familiar with the 3D system, we can work on our smoke cards. Let's go ahead and we have to read in our smoke footage. So I'll press R and let's bring in our hero assets _ smoke, which looks something like this. So this is just a simple render I did. It's a simple smoke simulation in Houdini, and rendered it in sort of a flat lighting so we can use it in multiple different kind of situations and let's say lighting conditions. When you want to create this sort of layer that you want to use as an element as part of your composition, you want to avoid super strong directional lights or very harsh contrasts in this case smoke. So we would want to avoid having like a let's say a directional light that's heavily skewed in one direction, because if we keep things flat, this would allow us the greatest flexibility in order to blend it in any lighting conditions that we have with the rest of our comp. So from this render here, we have to map this to a card, sort of like we did earlier. So let's reset our timeline. We can also see here that our timeline is now going from 1001 to 1450. And this is because this sequence is up until this 1450 frame and we are using the global here. So if we were to switch this to input, now our timeline is mapped to 1050 and 1450, which is the input of our footage that we are previewing. And when we set this back to global, now we have this up until 1450. Now let's go ahead and press S, and for our frame range here, let's set this to 1240, which is the range of our original render, and our global timeline will now match this 1001 to 1240 frame range. We also see that since this footage starts from 1050, in this case we have to offset this animation slightly so we can do a time offset. And if I want to push this 50 frames forward, we can set the time offset here to -50. So now if we go over at 1001 and play the animation, we should have this playing. And now also with this time offset, because we have 400 frames to play with, so from 1050 to 1450 we have 400 frames, and the total length of our final comp is going to be 240 frames. We have around 150 frames that we can offset, so when we duplicate this later and assign it to different cards, we can also do a time offset for the duplicates, and in that way we can create very easily variations between our copies. And we'll see how all of this works in a second. But now from our time offset, let's straight away append a card node over here. So this will hook it up to a card geometry, which we see over here. So now we can just push this into space and we will line this up with our geometry. Let's go ahead and also grab our camera, which we already have over here. I will grab this camera node and let's copy this and let's paste this over here. And we will also, while we are previewing the position of this geometry, we will want to reference our position to points node, which we had set up earlier. So let's go ahead and we can drag this node all the way at the bottom here, and let's actually make some more room. I'll grab all of these nodes and I will just drag them up like so, and maybe drag all of my setup here with the card up as well. So we have our camera, our card, and let's go ahead and preview our position 2 points. So here we have it. If I zoom out, we can see our entire geometry. We can see that our card is pretty small. So now what we can do is just drag this in space and position this. Let's go ahead and increase the uniform scale here. And we can see that this position 2 points is essentially just a point cloud. We can see that it actually intersects with our geometry. So our card geometry actually intersects with all of our points. So for example, if I want to place this behind this rubble over here, I can just roughly estimate where our camera is, or if I want, I can set where it says here default, I can go inside. If I have the camera selected, I can now select this camera 2 over here, and now I will view this position pass through our camera. So this is actually not our render, this is previewing this position pass. So our point cloud, we are previewing this from our camera, which looks exactly like our render. I can also go to the position points node over here and I can play around with the settings. I can make the point size bigger or smaller if I want. So from this camera view over here, I can select my card and I can see directly where I want to place the smoke layer. I might want to bring this up a little bit, and I can also play the animation now slightly, and we can see that everything is working. Maybe I'll make this even bigger. Let's do something like this. We can always adjust this later. So let's say that I'm happy with how this looks. I will drop down a scan line render. Let's point the cam to our camera, and our object slash scene will point this to our card. And now from our scan line render, let's press tab, and here we have it. From here, I can basically just do a merge, and if we merge this on our, so I pressed M to drop down a merge, this will be my A layer, and my background layer will be our final comp, or rather our comp so far, so our main chain. I can drop down another dot over here, and this is my setup with the card. Now it's not intersecting anymore with our geometry because we are just plussing this card on a sort of like a 2D image. So this is a 3D card, we are plussing it over a 2D image, and I will show you how we can actually blend this in a second. But first, what I want to see is if this lines up with our camera. I'm just going to select a small region over here over a few frames, and I will hit play, and let's see if this is following the camera. All right, and we can see that this works, so this is fine. I can still go in my card settings over here with double click, and maybe I want to position this a little bit more. I might want to scale this up, maybe bring this up slightly. So this is fine, but again, the problem is that we are no longer obscuring our smoke with the geometry. And what we can do here is we can use the depth map that we used earlier to create a mask and isolate this part of the, in this case, this pile of rubble over here. We can push our depth information far enough until it reaches the rubble, and then use that as a mask to cut out a part of our smoke. So this will only make sense probably as we start to create this mask. Let's go ahead and we'll need another shuffle. And in fact, we will need the same shuffle that we used in our fog over here. So this depth with no AA. So we want the version with anti-aliasing, or rather with the smooth edges. So we can copy this. Let's Control C and Control V to paste this over here. And we will point this back to our original render. Let's point this arrow to this dot, and we can rewire this maybe a little bit. Let's do something like this, and I'll just drag this position points node over here to the left, and with our depth pass over here, we want to use this as a mask. And remember what I said earlier, when we want to use it as a mask, we just need to use the alpha layer. So I will disconnect all of this, and I will just connect our depth over here to our alpha. And for now, let's set this property value here to 1, so we are just focusing on the currently selected node. So from here, if I press A, we have our depth information here, so I can drop down a grade with G. I will set the channels to RGB, or rather to alpha, because we only have the alpha channel now. And again, if I increase the white point, if we remember from earlier, roughly a value of 400 will be our furthest point away from the camera, which is this building here. But we don't really want to spread this range specifically. What we want to do is have a rather narrow range, but we want to offset that range or push that range into Z space. So what I mean by this is, if I were to set this to a lower range, if I were to just use a value of, let's maybe make this fade over 20 units. So I will set the white point here to 20. We can kind of see a little bit over here. Let's maybe make this even smaller. So I will set this maybe, let's do 5 instead. And now we no longer see this. If I want to push this entire gradient along our values, I can use the offset adjustment instead. So if I want to push this further, I can decrease the offset value. And if I decrease this enough, we can start to see, as I push these values, we can sort of see how this gradient that's over 5 units. So if we imagine this white to black value is spanned across 5 units in 3D space, we are just pushing this value into this Z space. So farther so further away from our camera until we sort of isolate the rubble, or rather the pile of rubbles that we are interested in, which is going to be this one over here. So we can see now that we finally reached our rubble, and this is exactly the mask that we want to cut out our smoke. So what I can do now is, if I go back to the scan line render and let's press A to get out of the alpha view, we can drop down a gray node and we can point the mask to our channel that we created over here. So I will point the mask to our grade over here that points to our shuffle, and if I lower the gain, we can see now we are getting the reverse of what we want. If I were to preview this from our final result, we can see now that we are kind of keeping the smoke that's in front of the rubble, and we want the reverse effect of this. So if I go to the gray node, I can set this option here for the mask. I can check invert. So now we are getting the correct result. We can also see that we are left with this dark shadow, and this is because we are affecting only the RGB channels. So if we go to this gray node and press A, we still have the alpha information for the smoke that's in front of the rubble. So we want this grade adjustment to also affect the alpha as well. So we will so in this case, we will set this channels to RGBA. So now if I press A, we also have this alpha, and finally, if we preview the result, we have this now nicely integrated with our render, and it really looks like it's behind our rubble over here, even though it's just a random 3D card placed in the 3D system. So this is with and without our grade adjustment, and now we can still go back to our card. We can make this maybe slightly bigger, and now our mask adjustment will persist through our 3D changes, which is really great. And if we want to further control this transition more, we can increase the spread of our ramp here a little bit. So if I were to increase the white point, we can see how this changes. So maybe I want a little bit more interaction with our rubble. We can change the offset. We can bring this slightly forward, and I think in this case it's actually working out pretty nicely. We can play around with the gamma as well, so we can see how much control we can get with this technique, and really how flexible this is. Now from here we can still do some grading adjustments. So if I drop down another grade node, maybe I want to lower the gain a little bit. We'll probably revisit all of these settings later as we add all of our, or rather the rest of our elements, and then we'll start from the top and work our way down to the bottom. So we'll start back with our sky and our fog and readjust all of the elements. One final thing that I might want to show you here is if I just preview this channel, or rather this smoke layer in isolation, we have alpha channel. So when we preview the final result, if I were to drop down another gray node, and this is something that I usually like to do, this gray node I can set to only affect our alpha. And if I want this smoke to be less opaque, because we are using this merge operation, which is set to over, the way this is blended with our compositing will depend on the alpha. So if I have this gray node set to alpha and I reduce the gamma, we can see how we can sort of start to make the smoke more transparent, but only around the edges. So as I decrease the gamma, we are keeping some of this opaqueness in the center of our smoke, but we are reducing it towards the edges. So this is something that you can play around with meaning a grade node set to alpha. Feel free to experiment with this. So usually I have a grade node that's just set to alpha and one other grade node affecting only the RGB values. So I can make this overall darker, and with our second grade node I can affect the transparency directly. So really between all of these techniques you get a lot of flexibility and a lot of options. Let's maybe make some more room here. So this is the setup, and now we can just copy this setup very easily. So what we have to do from here is I can grab all of these nodes, including the merge. I will press Alt-C to duplicate all of them, and all we have to do here really is connect, or rather reconnect, the shuffle to our render. Let's maybe make some more room, and let's bring all of these layers down below like so. Bring this up. So now this shuffle over here should point to our main render. So I can just grab this node and just point this to our other dot where we have this connection. So we should have exactly the same setup. I can merge this on top of our result. And now with our second smoke copy over here. Let's maybe reset the timeline. Let's also change the time offset here. So I might want to push this maybe 50 frames more than our previous one. So I'll set this to -100, just so we are in a different part of the animation for the duplicate, and this will help us with variation, and very easily we can add more detail this way. So now I can grab the card and let's preview the card, and let's also preview our position 2 points pass. So with this card selected, let's make sure that I'm selecting the right one. All right, and let's make sure that we are previewing more properties since we are dealing with 3D. So I'll set this value here to 5. Let's preview the card, double click the position 2 points, and let's go back to our card so we can now position this in a new spot. Again, we will try to sort of match where our rubble is essentially. Let's do something like this, and I will disable the grade, all of these gray nodes, and just focus on the positioning for now. So if I preview the merge result, it's over here, which is looking pretty good. Maybe we can bring this over, we can play around with the scale, make this bigger or smaller, but this is fine. I might want to introduce a little bit of variation on the Y as well. I might want to just rotate this plane, not so much. Let's undo this. Let's try to set the values here directly. Let's use -5 and just maybe rotate the plane, maybe -20 on the Y should be good. Introduce a little bit of variation in the rotation as well. And now what we have to do with our grade here for our depth mask is find the right offset. So I will try to push this further until we isolate this rubble over here. So I will just increase the offset until we get the rubble that we are interested in, which is over here at this value, so around 9 units. And now I can re-enable all of our mask adjustments. Let's preview this and let's preview the RGB. And here we have it. Maybe in this case, I will want to brighten this smoke overall. I might want to go back to our mask. Let's set this back to 1. So I might want to play around with the offset. Let's maybe just isolate this entirely from the rubble. All right, so here we have it, and we can preview some frames here as well and see what we get. So I would say this is looking pretty good. It's fairly believable. I might want to isolate more of our rubble for this first layer of smoke that we have here. So this is the part where you just go back and forth between the settings and you readjust things until you are satisfied with the results. So maybe I will just decrease the offset here and just place this more behind our rubble instead of what we had earlier. And one other thing that we can do here, we can see if we look at just our smoke render, it's really flat on the ground. I might want to fade this off towards the edges, just to help us blend it more with the environment. And we can use a radial for this. So if I drop down a radial, we will try to match it with the resolution of our smoke. So in fact, what I will do is I will select this reed here with the smoke, and then I will drop down a radial, and now this will place the radial exactly in the center. So I can now grab this gizmo here for the radial, and while holding down Control, I will just scale this up like so. Maybe scale this even more, and I will use this gradient to fade off the smoke layer itself. So now I can disconnect it from our render, and from our render I will drop down a multiply, or rather a merge node, which I will set to multiply, and I will point the radial back at our smoke so we have the same resolution on both of our smoke and the radial. So now if I were to enable and disable this, we can see this is the result that we get. And I can maybe decrease the softness, and I can increase the area. I can maybe mask things out a little bit more. So with this extra layer, we might have a smoother result where it intersects with the actual ground. So if we take a look at our result from over here, I might want to increase the brightness of this smoke. But essentially, if we look at this result with and without our radial adjustment, we can see it's more nicely blended with our environment. So in fact, we will want to copy this setup for all of our cards as well. So I will just grab all of these nodes. Let's copy them and let's replace this render from our time offset over here. All right, so now our second radial as well, or rather our second smoke element as well, will have this smooth fade or on the ground intersection. So again, here as well, if I were to enable and disable this, in this case for our second layer, it doesn't really make much of a difference, but it's still something nice to do with your elements. And let's do one more and place this behind this rubble as well. So again, we just have to copy this entire setup, grab all of these nodes, Alt C. Let's connect, or rather reconnect our nodes. And whenever you have a connection that has to like sort of travel a big distance, if you want to make a forward connection, so if you want to connect this node over here to this node, you can select the first node that you want to connect, hold down Shift, select the second node, and then if you press Shift Y, it's going to draw this forward connection between the two dots. So now we can see this is connected and everything still works. So this is our duplicate. Let's go ahead and disable all of our gray nodes, and let's grab our card and let's just place this forward. I'll press W to go in my move gizmo. I know it should be somewhere around this part. Of course, we can now set this value for properties here to 5, and let's also select our position to points, pass, select back our card, press W, and let's see where our rubble should be. This should be really somewhere in front over here. I will probably have to scale this as well. Let's grab our uniform scale, drop this down, place this down below, and somewhere around this place should be okay. Let's preview this from our render. We will merge this in our chain. Let's go ahead and preview this, and from over here I can say that this should be offset a little bit on the X direction. And also for this time offset, let's push this out even more, maybe to 25 frames more, just to maintain that variation. And now we can enable our gray nodes again, and we will need to find the right offset. And let's go ahead and set this back to 1. And for our gray node pointing to our depth, we will want to bring in the offset until we isolate this rubble right in front, somewhere around this place, I would say. So now if we preview the result, we have our third copy over here. We can go to the gray node, we can make some further adjustments, and also on our alpha as well. Maybe I'll drop down the gamma, overall make this a little bit more transparent. And let's go ahead and preview some frames with our third copy as well. All right, so I'm pretty happy with this. All of our elements are nicely integrated with our 3D scene, and this is where we have combined our 3D system with the utility layers, and hopefully you can see how everything is coming together. And now you have a small idea on some of the things that are possible and the flexibility that you have in compositing. And really here I'm just scratching the surface. You can really go pretty insane with some of these adjustments. You can really build an entire world and tell any story that you want through compositing. So this will be good for now. Let's go ahead and grab all of these nodes and let's organize things. Grab all of these and place them down below. So all of this here will become, let's draw a background, and this is going to be our, let's just simply keep this as smoke, and let's maybe choose another color here and saturate this, darken this. So this will be our setup with the smoke, and adding just a few of these smoke layers can really help make your scene come alive, especially with environments. Whenever you add a subtle thing that's changing over time, it's really going to help you break up that static sort of feeling. So if we were to compare this with our original render, if we just look at this, even in isolation of all of the color adjustment that we did, if we look at this and then we compare this with our smoke on top, we can really start to sort of get a feeling that this is an environment that's actually alive. So it's always worth adding a little bit of movement, whether you are breaking up the fog or you are adding certain elements like these smoke layers. It's always worth going this extra step to improve your shots. whether you are working in CG or with real-life footage. This is something that you will encounter over and over. And with the next lesson, we can take a look into how we can create our own layers directly in Nuke to contribute to this coming alive of the environment feeling. So I will see you there. So for the next layer, we will want to create a very thin, sort of wispy kind of smoke that goes over the ground, specifically over the entire ground. And we can use all of the techniques that we know so far. We will create a plane, which we will place on top of our ground in a 3D system. And then we are going to mask out parts of our geometry based on their height. So first of all, let's start off with a noise. So I will drop down a noise and make sure that this is the version that has this draw in between brackets. So when we preview this, we've used this before, so or rather I've briefly showed you this when we were breaking up the fog. But this noise layer is essentially just a pattern which we can control and further refine to suit our needs. So we can see we can increase the size here, we can play around with the linearity, gain, gamma, and so forth. So this noise is really helpful. I use it in pretty much every comp that I have ever done. You always want just a little bit of detail, or you want to break up certain parts of your geometry or your other layers. So this is extremely useful in this breakup type of situation. But in this case, we want to use this to create our own sort of stock footage, so to say, that will become this kind of wispy smoke. Now, here previously, we have used an actual rendered file. So I've created this in Houdini. You could have also used maybe a live action plate of this kind of smoke animation. Now, whenever you have the option, you should always use pre-rendered elements or filmed elements, because obviously that will give you the most realistic results. But in some cases, you can just simply fake some of these layers directly inside of Nuke if you combine some of these noises with distortions and so on. And this is what I want to show you with this layer, how we can leverage the simple noise texture to create this kind of wispy smoke on our ground. So first of all, since I want to use this as more of a texture, I want to make this a square format. So if I do a reformat node over here and I set this output format, usually I like to use either 2K or 4K for this kind of situation. So in this case, 2K will be just fine. Let's choose here square 2K, and I connect the noise to this reformat. The noise will now be mapped on this 2000 by 2000 grid, which will be kind of like the way a texture is mapped. So now if I use this on a card, we can drop down a card geometry from here. We want to rotate this so it's flat on the ground. So I will grab the rotation gizmo here with E, and I will just turn this around. We want to use here a value of -90, and we want to animate this noise so it goes across the ground from left to right. And if we go to the noise properties here in the transform tab, we can see which of these parameters we want to animate. So if I were to increase the translate on the X, let's maybe take a look closer. Now it's kind of hard to tell because we keep flickering this texture as we are previewing the changes. So the way that we can animate values inside of Nuke is we can add keyframes. So if I wanted to animate this translate X value, I can go to the beginning of the timeline. I can right click and set a keyframe. This will now show up on our timeline here. If I zoom in real close, let's maybe zoom in here, we can see that there's this blue underscore kind of thing, and this indicates that there is a we have set a keyframe. And now I can go to the end of our timeline at 1240 and I can increase this value. And if you have already a keyframe set, whenever you make changes to that value, it will automatically add a new keyframe. So now I can increase this value here and we can see that this will add automatically a new keyframe for us. So now our noise is animated. So we can either animate values through keyframes, but in this case, since I want just a linear animation, I just want to increase this value over time, we can map it to our frame number. So let's go ahead and I'll get rid of the keyframes here. I will set this to no animation. Let's hit yes. And instead of setting keyframes, we can right click and choose add expression. And now I will simply link this to our frame number by typing here frame. And we can see we already have a result since we are on frame 1130. This will give us now, this will output 1130. So if I hit OK, we now have this value here. And as I move forward in time, we can see that our, and by the way, I'm using the left and right arrow keys to move back or forward a few frames. So we can see that as I move forward, this value now increases. So if I were to zoom in here and just simulate, or rather play the timeline and cache a few frames, we can see that this is the animation that we now get. So if we want to have this animation move faster, we can go back in our expression here. We can right click, choose edit expression. And if I want to make this twice as fast, I can do multiply 2. So now we essentially doubled the speed. I can hit OK. I can preview this now, and we can see that this is now the animation. And also we are animating the noise in the correct way because, like I said, we want to move from left to right. Let's place this now in our 3D scene so we can better judge what changes we need to make. So let's grab our camera, and also we can grab this scanline render as well. Let's copy this and let's paste this over here, and I will connect the OBJ to our card. And if we go through our look through our scanline, we can't see this because we still need to position this. So let's also preview our position to points node over here. Let's preview this and let's change the properties here to 5 so we can preview multiple nodes. And if I go now to our card, we can see now that we have to bring this card way further back. So with W, I will move this card. Let's increase the uniform scale by quite a lot. And we want to cover at least the closest part of the ground, so the closest to our camera. So let's move this over here. Let's increase the size. We'll do something like this. So now this should probably look a lot closer to what we need. We can also maybe drag this up slightly. I do want it to intersect with our ground a little bit. This will help us to integrate our smoke more. And if I were to merge this from here on our existing chain so far, so I'll just drop down a merge and just put this over with an over operation. Let's go ahead and preview this, and here we can now see our smoke. So we are almost there. We still need to increase the size of our card, so let's go ahead and let's make this even bigger. Let's make this really big so it covers some of this part over here towards the that's further away essentially from our camera. I might want to push this further out even, but we can kind of start to get a feeling of what this will look like. And if I were to, let's preview some, let's cache up some frames so we can also have an idea on how fast the smoke is moving since we have this noise animated. All right, so I'm pretty happy with this. I think we will keep this speed as it is. And one more thing that we can do for our noise, we can also evolve this noise over time. So if we go in the noise tab, this Z property over here, we also want to animate this over time. We can see how our pattern changes when we increase this Z value. So here we will do right click, add expression, and we want to map this to our frame value as well. So we will do frame. Only in this case, if I leave this at the frame value, we can see that the animation will be really fast, and we want to really lower this value. We want to multiply it or rather scale it down by quite a big factor. So let's right click, edit expression, and let's multiply this. Let's say that we want only 10% of this or maybe even less. Let's do 0.05 and let's see how this speed will look. And probably this is still even too much. We can also right click and choose edit expression, or we can select the value and press equal sign, which will bring up this expression window. Let's do 0.01 instead. Probably this is even still moving too fast, but actually I think this is a lot better. So if I preview this from our merged result over here, let's cache a few frames. So now we have this result. It's looking pretty good. We might want to make this evolved speed even faster. Let's go ahead, go back to our expression window. Let's do our final value here, 0.02. So this should be fine. Now let's see if there's a way in which we can make our noise look a little bit more thin thin and a little bit more wispy. I'm essentially looking for kind of like sharp lines in between our pattern. So if we go to our noise, there's different types of noise that we can use, and let's use turbulence instead, which we see now that it's a different kind of pattern, and this will provide for us these thin wispy lines which we want, but we want these lines to be white and the background to be black. So we want to reverse this. So after this noise, we can drop down an invert node, and let's make sure that this invert is going after the noise. So let's reconnect this. So we have our reformat, our noise, and then the invert, which gives us this result. And now from here, we can go back to our noise, and we will reduce the linearity a bit. If we reduce the octaves, this will make our noise overall smoother. So in this case, we do want a smoother result. Let's maybe use octaves 4. Let's drop down the gain as well. Maybe let's increase the gamma. In this case, we can kind of start to see our lines. And after this invert, we can simply drop down a grade and we can control our smoke this way. So now we are really starting to see the pattern that we are after. We can even reduce the gain here on this grade node. And maybe this is still, we are getting too much detail. We can go to our noise and we can reduce the octaves maybe to a value of 2. So I think this is a lot better. Let's reduce the gain maybe. The gain will overall help us decrease some of the level of detail, and probably the gamma is looking all right. Let's see how this looks from our rendered view. All right, so this is a lot better. This is exactly what I'm looking for, these thin wispy lines. But now I might want to overall increase the pattern of this noise. So in our noise settings, I will go to the size here and just increase this. Let's maybe make this an overall bigger pattern. So something like this. And maybe I don't want this gamma to be this low. I might want to push out the gamma and maybe just overall decrease the gain. Now I'm not gonna spend too much time adjusting these values. I'll leave this up to you because I don't really want to waste too much time fine-tuning settings here. But one final thing that we can do with this noise pattern, so we have this. Let's actually preview this from our grade node. So we have this pattern so far. We can now combine this with other noises. So if I do another noise pattern here, let's use draw. Let's also format this to our 2K view. So we have the same noise that we started with. Now here we want to use this to multiply our existing results. So we can combine these two layers of noises now. I can drop down a merge node here and I can multiply our second noise. Let's set the merge operation to multiply, and we can see, let's maybe reverse the order so we can toggle off the A layer. And we can see with this extra noise layer on top, we introduce even more detail. So for this second layer of noise, let's maybe just increase the gamma, and also I want this to be smoother, so I will decrease the linearity. Maybe the size is pretty alright. I might want to try to overall just make this more smooth. Maybe let's increase the size slightly, and we also want to animate this, but just on the Z I think will be fine. So let's go ahead and press equals here, and let's do frame multiply. Let's use the same value, 0.02, which should be a smooth enough animation for us. And if we preview now our texture from over here with this additional layer of noise, we get something like this. So that's pretty cool. And we can preview this now from our actual comp, and this is what we end up with. Alright, so I think this actually works pretty well. I might want to decrease the speed, but again, I will leave this up to you to decide what kind of values you want to use. I'm pretty happy with this result, and we can see how easy it is to create our own elements, even if we don't have access to, like I said, stock footage or pre-rendered elements. You always want to use pre-rendered elements if you have any, but sometimes, or maybe as a proof of concept, you want to see if something like this could work, and then you can send it to the simulation department and ask them to create an actual simulation of this kind of wispy smoke type of movement. So obviously something like this would look a lot better if it was simulated in Houdini, but depending on how much emphasis a certain element has, you might not need all of that detail and realism. We can see that when we combine this with our other elements, this works just fine, at least as far as I can tell. Now, to make this even more believable, we will have to integrate it with our actual environment render. And in a similar way to how we merged our smoke footage by using the depth as a mask, we can use the world position as a mask in this case, because we want our gradient to go from bottom towards top instead of from front to back. So I'll show you what I mean by this. We've covered the position pass a little bit when we were using it to create our position to points layer over here. So this is only possible through our world position. Let's go ahead and we'll need a new shuffle that points to our render, and actually we can just grab one of these shuffle nodes from over here. Let's copy this and let's paste this down below, and again we will want to point this back to our render. We can go, we might want to add another dot over here. So this dot points all the way to our environment render. So from here I can just grab this node or rather dot, and I can hold down shift and select my shuffle and then press shift Y to create this forward connection. So now in our shuffle we want to shuffle. So here we will want to use our P pass. So this is the world position. When we select this, we have a similar thing here. We can see that we have sort of like the normal pass. We have X, Y, and Z coordinates. So in this case, we are interested in the height. We want to create a gradient on the height, which means that we want to use the Y value over here. If we wanted a gradient that goes across from left to right across our geometry, we would use the X, and on the other axis we can use the Z, but in this case we want to use the Y for the height, so we can plug this in our alpha channel. And if I press A, we can already see a little bit of this gradient. So if I drop down a grade node and I use the alpha channel over here, I can increase the white point if I wanted to increase this gradient. So if I want to increase the spread, essentially we can increase this. So we can assume that if one of these buildings has in units a height of we can actually check if we were to go to our shuffle version over here. If we look at this pixel value here, we can sample this. We see that it's 65, so this is 65 units. And if I were to go to our grade node and set the white point here to 65, we will essentially spread out this gradient across our entire building. But we don't want to have a gradient that's really this spread out. We want to tighten this up, so we want to use maybe from 0 to 1. We want a very sharp gradient like this, and we will use the offset like we did earlier to determine exactly which parts of our ground we want to isolate. So in fact, in this case, I can even lower the white point even more, just so I can filter out some of these pieces of rubble over here, and I can decide exactly how I want to blend in our smoke layer. So from our gray node here, we can go to our scan line, and let's preview the RGB, and let's go ahead and do the same thing that we did earlier. We can drop down a grade node from here. We can point the mask to our other grade node that's linked to our position pass, and now I will just set the gain value here to 0, and I want to run this over RGBA channels as well. And now here we have it. We have successfully masked this smoke layer with the height of our geometry. So if I were to disable this layer, we can see very easily we can create this blend between our element that we created directly in Nuke and our actual rendered geometry. So this is really cool. And again, we can go back to our grade adjustment here for our position, and I can play around with the gamma. If I want to tighten up this gradient, we can decrease the white point even more, or we can increase this. If I want some of this smoke to spill over the rubbles, I can just increase the white point, as we can see here. But in this case, I want to pretty much obscure it by our piles. So overall, this is just another example of some of the stuff you can do. And here we took it an extra step further by creating our own layer, which we didn't have to import from an already existing footage of this smoke. We created it ourselves with the noise. And again, we are really just scratching the possibilities here. And in time, as you experiment more yourself and as you watch more courses and tutorials, you will have more ideas on how you can combine passes and how you can create your own layers. So this will come naturally in time as you use Nuke more and more. So let's maybe just cache a few frames with this as well and see what we get. But overall, I can say that I'm pretty happy with it. It's pretty believable. Again, for this type of shot, our main element is actually our character. So we are not, the eye will not really focus on the specific ground fog layer that we created. So it will only register as something that's going on in the background, and it will just help us create more depth to our scene. So with our elements, with our smoke elements, we added depth from front to back. And in this way, we are creating depth from bottom to top. But we are more or less done with this extra new layer. So we can go ahead and also do a backdrop here. Let's make this bigger. We can name this one ground smoke or something like this. Let's make this darker. And more or less, we are pretty much done with the environment. And with the next lesson, we can start working more on our character. So I will see you there. Now, for the character, we'll take a closer look at what we can do with our passes over here, so with our shuffled setup. But first, I would like to add one more layer of the same smoke element that we used in the environment in front of our character as well. So we want to integrate this with the character. Let's go ahead and I want to show you a new node, which is going to be the PostageStamp node. So essentially what a PostageStamp is, it's just a connection to another to a different node in your chain. So for example, if I were to place down a PostageStamp node and connect this to our smoke layer over here, so to our read node, we can see this PostageStamp will create a thumbnail of what it's pointing to. So it's really just a bridge between these two nodes. It doesn't really do anything. It just holds whatever layer you are pointing towards. And this is great because, for example, if I wanted to change this smoke asset now, so if I want to replace this render, let's go ahead and let's maybe just replace this with our character render. We can see that our PostageStamp changes as well. And this is particularly useful when you want to duplicate elements or you want to create sort of like a connection. And this is also helpful when you want to keep things organized, where you don't really want to rewire and bypass an entire kind of chain or rather network. So essentially with a PostageStamp node, now we can, let's go ahead and undo this so we can point back to our render. With this node over here, I can replace all of our read nodes with our other smoke elements, which is essentially the same render. So I can just rewire all of these other nodes to point to the PostageStamp, and I can get rid of this read node over here. So now we can see that we have the same result. If I look at this result over here, we have the same smoke asset. And again, this is great because now, again, if I wanted to change this render, so let's say that maybe, for example, I want to experiment with different kinds of smoke assets. Maybe I have different version of this render. I would just have to replace this single read node over here. And if I just replace this real quick with the character so you can see this, we can see that our other duplicate changed as well. And if I look at the result now, this doesn't make any sense, but now they are both pointing to the same render, which is what we want. So again, I will undo this so we go back to the smoke. And if I want to hide any wire connection for any node, we can go over to the tab over here, and there is this option where we can hide input. So now when I click off of this node, this wire will only show if we select the node, which is really helpful to keep things organized. And you can do this with any node. For example, in this shuffle node, I can go to the node tab over here, hide input. So now when I click off of it, we hide the wire. So again, this is strictly an organizational technique. We can also use the hotkey Alt-H. So I will use this from now on when I want to hide a wire. So this is Alt-H. We can see it turns on and off this option. So with our PostageStamp node, let's replace our third read node as well. So it's all pointing to the same same render, I will press Alt-C on this PostageStamp. We'll bring this down below over here. And again, if I want to create a forward connection, I want to connect my render to this new PostageStamp. I will select the render and I will Shift select the PostageStamp. Let's press Shift Y and we create this forward connection. And now we have this hide input turned on. So when I click off of it, we no longer see the wire. And now I can rewire this render to our PostageStamp, and if we preview the result, we have all of our nodes, and we can very easily just change this single read node and it will update throughout the chain as well. So now with this being done, I want to add another smoke layer in front of the character. So again, I can drop down a PostageStamp. Let's grab our initial read node over here, Shift select the PostageStamp, and then press Shift Y to create a connection, Alt H to hide the wiring, and here we have it. So we can essentially merge this on top. I drop down a merge with M. We can place this over here. And first of all, we would have to format this in this case. So in this particular case, we no longer need to place this on a 2D card in the 3D system. This will work just fine if we just merge this on top, because this is super close to the camera and the camera is orbiting rather slowly. This won't really make much of a difference if we just leave it as a sort of static render on top of our image or place it on a 3D card. It's not gonna move that much. So in this case, we are just going to leave this as it is, not use a 3D system at all. But from here, we see that our resolution doesn't match. So we will have to do a reformat first of all. And let's do a transform node, and we can now position this. So from our final result, I will grab the transform, and while selecting this gizmo, we can see that we can move this around. I can increase the scale here. Let's maybe increase this a little bit. We can do something like this. And I don't think we've used this transform node anywhere so far, but this transform node is pretty self-explanatory. You can scale things up and down, you can move them around, you can skew, you can do all of the regular transform rotations. So I'm sure you are used to working with something like this. One thing happens here when we scale this up and we move it around, we can see that we do have this bounce extended on our comp. So now when we merge this over, we are working with this resolution over here, and we want to limit our elements only to the format size that we are actually using. So our root format, which is 1920 by 1080. So if you end up with stuff like this when you merge things over, so this extended kind of bounce, it's always worth adding a crop to your layers, which will limit it exactly to the size that you are using, so the root project format. And this will make sure that these areas over here won't take any more computational power than it needs to. Because, for example, if I were to not have this crop node over here, and let's disable this and I add a grade node, or I do other operations, and again, let's disable this. So when I do this grade node, this will kind of take into account this extra space here around our image as well. So it if you have a lot of elements that are not cropped, this has the potential to slow down your comp. So it's always good to limit the size of your layers to the actual format that you are using. So we can see that right away we have a pretty decent result, but we do want this to interact with our character. So we can grab the depth map of our character to make our smoke interact with the character. So with that being said, we can grab a shuffle node. Let's copy one of these nodes and we will point this to our render directly. So not we don't want the unpremulted version. We will point this to our render and we'll bring this down. And again, we can just hide the connection of this wire if I press Alt H on this node, and now we will not see it unless we have this selected. So from over here we have just the depth extra, which is kind of like that unpremulted thing that we've talked initially, and this is simply because I forgot to set up the depth width anti-aliasing in this case for the character, but this this will be fine. So if I want to use this, now I mentioned that usually we place this inside the alpha if we want to use it as a mask. So if I press A, here we can see it. But in this case, we have to take into account all this black space around our character. So I will place our depth in all of our RGB channels, and I'll explain a little bit more in a second. But now if I drop down a gray node and I keep this at RGB, I can lower the white point to squeeze in the ramp, and I can just push the offset in negative space over here until we should hopefully, and let's make sure that we are not previewing the alpha, so we are in the RGB view over here. So if I push this in the offset value over here, we can see how we can slowly start to isolate the parts of our character. So maybe I want the smoke to ignore everything that's black on our character, so we have this nice interaction. So the problem when we do this as it is so far, if I were to just use this in the alpha channel, I will just show you this real quick. So let's set the grade to work on our alpha. All right, and if I press A, we now have this alpha information. If I were to drop down a grade from our crop over here and do the same thing that we did with our smoke earlier, let's point the mask to our grade and let's set this to RGBA and turn the gain all the way down to 0. We can see what happens. Let's do invert over here. So we have this interaction with our character, but it is cropped only to the alpha of our character as well. And this is because if we just look at our grade information here and press A, this is essentially the map where our smoke will be visible, but we want the smoke to be visible in the entire region around our character. So we need everything that's behind our character essentially to have a full value of 1. So we want this alpha channel to be white. Now the easiest way to do this is if we just use the RGB channels instead. So in the shuffle, I will again, we want to shuffle this in the RGB channels, and in the grade, let's set this to RGB. So if I press A to go into the RGB view, we have the same result. But now what I can do is I can drop down a constant and I can set the RGB values here to 1, and I can set this as the background of my character. So if I press M, let's point the B layer to our grade and then reverse this because we want the constant to be the background, so the B layer. And if I look at the result now, we have exactly what we need. So now we can actually point the mask to our layer. But now that since we are using the RGB channel, so if I press A, we only have the alpha of our depth, and we want to use one of our RGB channels. So in this case, we can just use the red channels. We can see that if I were to inspect the pixel values here, if you look at the bottom of the screen here, so if I were to sample a region, we can see that all of the RG and B channels are the same value. So really here in our grade, we can either use the red, green or blue. Let's just use red, and now we see that we finally have the result that we are after, and we can still go back to our grade node and we can push the offset, and we can see this very nice interaction with our character. So again, we are doing the same thing, and now I'm going to point the merge to this grade node, and if I look at the final result, we can now go back to our grade for the depth adjustment, and we can push the smoke back into our character or have it be more in the back or in the front. So we have this option to control exactly how the smoke interacts with our character. So now it kind of feels like there's a little bit of smoke that's going in front of the character, and some of the smoke is going behind our character. So we have this very nice interaction. The reason that we didn't have to do this background trick over here for our initial smoke is because we had enough information from the environment to avoid this kind of thing. So if we look at some of these alpha masks that we created here, for example, on our first layer, if I press A, we see that most of this background is already filled. So our smoke being over here, we didn't really need to create this kind of flat background for these layers in order for this to work pretty nicely. But for example, over here on our second layer, if I look at our second mask, we can see, if I actually look at the result, we can see that this is actually cropped by the building. So in this case, we would have to do the same trick with the background, but it doesn't really make much of a difference in this case. But if I were to let's go to the RGB values here. We can see that it really doesn't feel like the smoke is cropped around this building over here, even though actually it is cropped. We can see it. This is what we are merging on top. So we would technically have to do the same kind of trick for all of these layers. So depending on what kind of depth map you have, you might have to do this or you might not. For example, if we had this character render, if we had a depth layer that's including both the character and our environment, we would probably not have to do this kind of trick over here. But since we just have our character, then we have to fill in all of the black space around the character as well. So this will be all right for our smoke layer. Of course, from here we can still drop down a gray node. We can increase or decrease the gain. We can also drop another gray node for the alpha specifically. So I'll set the channel here to alpha, maybe drop down the gamma or the gain, make this more transparent. So probably this works a little bit better. We can still go back to our transform and reposition this smoke. And let's maybe just cache a few frames and see if everything is lining up correctly. And by the way, if at any point you have an annoying gizmo like this on your viewer that you want to hide, you can just press Q and then you can see this turns the overlay to off, and then we can, with Q, we can turn this back on again. So sometimes really helpful when you want to preview things quickly. Let's again just cache a few frames and see what we have. All right, so I'm pretty happy with this. We have this nice interaction of our foreground smoke with the character. So let's just do a backdrop here, and we can call this, let's call this FG for foreground. So FG smoke, let's do this, let's make this another color here, and we are pretty much done with our foreground smoke. And with the next lesson, let's take a look into some of the options that we have to really fine-tune the look of our character. So I will see you there. Going back to our character setup, we can see that if we were to grab a specific AOV, we can do changes for that AOV or for that render pass. But let's say that, for example, in the case for this reflection pass over here, I really want to isolate a certain part of my character. So if I look at my character as it is, I really don't want this the blade of the sword to be as bright. So it would be really handy if somehow from this pass I would drop down a gray node and I can gain this down, but I only want to affect this part of the sword. And this is where the Cryptomattes come into play. So Cryptomatte is another kind of utility layer that you can use. So we could go to one of these shuffle nodes and we can kind of see some of these crypto object passes over here, which look something like this. Now, this isn't really how you use Cryptomatte, so let's go ahead and undo this. For Cryptomatte, since it's more of a special kind of pass, we will need to drop down a Cryptomatte node. And with this Cryptomatte node, we can point this now to our render, and we want to do this before the Unpremult. So if we were to preview this, it looks something like this. It's essentially an ID map of our materials. So this will depend on how you set up the Cryptomattes in your render engine. But in this case specifically, I separated the materials. So wherever we have a different material, this will correspond to a different color. And we can see that the blade has a different material, the hilt has a different material, our character has a few materials. And now what we can do with this is, if I want, for example, in our case, we want to isolate the blade of the sword, I can hold down Control and I will click on this sword. Now we can see this blade turns yellow, which means it is selected. And if I press A, we can see that this will now translate to our alpha channel. So I can now go back to our reflection pass over here. Let's go into the RGB view. And if I want, I can drop down a gray node, point the mask to this Cryptomatte. And if I lower the gain, let's preview the result from over here. When I now lower the gain, we can see that only the blade is affected. We can preview this from our final result maybe. And hopefully this will now show you the power of Cryptomattes. It's something that you will most likely use in any kind of CG composite that you do. So very, very handy. And let's go back to our Cryptomatte. And in this case, for the Cryptomatte, we have to take into account we have to unpremultiply this as well. So if I press A, we can go to the unpremultiply, and this will now get rid of the aliasing because all of these layers here, which we are working on, are unpremultiplied. So we will have to take this into account. We can see that, for example, in this Cryptomatte, if I were to turn off this unpremult, we kind of get different grading around our edges. So again, we have to take into account this unpremultiply business. For the Cryptomatte, we have to specifically unpremultiply this here. So let's maybe first try to organize things a little bit. Let's do something like this so it's a little bit cleaner. So let's go back to our Cryptomatte and inspect some of our other settings here. So while holding Control, I can select even more parts of our character, and we can see that all of this will merge into a single alpha layer. If I press A, we can, this is currently our option is set to pick or add, but we can remove if I set this to pick or remove. And now with Control, I can deselect objects, and we can also see that as I start to add more objects, we also have them here on our list. So this is how they are separated. This here is essentially our material path. So this is really cool as well. I can even deselect them if I were to just simply remove them from the list. So I can also do this. I can hit clear to get rid of all of the selections. So it's pretty easy to use, not really worth spending too much time here. Let's go ahead and just keep our blade selected, go back to our grade. We can just grade this down, and this should be fine. Let's maybe go back to our render, and also maybe I want to lower the intensity of this hilt here as well. Let's take a look at some of our other passes. I might want to use a different kind of mask for this one here, for example. So I can just duplicate the Cryptomatte node with Alt. Let's go ahead and connect this to our render as well. Maybe we'll bring this all the way over here. And with this Cryptomatte, let's clear and let's control click on the hilt. We'll do a grade node for our shuffle. Let's point the mask to our Cryptomatte. So now I can gain this down. We can preview our results now. Let's enable some of these one by one, and I'm pretty happy with this. Let's take a look at this layer specifically. We might want to drop down a grade node here that points to the same sword alpha, and we might want to gain this down. Let's preview this from over here. We might want to lower this a little bit. We can play around with the gamma as well. And our final layer, this looks all right. And now if I preview the result, this is what we have. So if I were to disable all of our grading adjustment with the Cryptomatte, we can see we can make very, very specific changes. Probably this is too much. I might want to bring back some of this reflection and specularity. I might want to play with the gamma instead rather than the gain. And we can do something like this. We can always come back to this. Essentially what we are doing here is we are just setting up all of our options that we have so that later when we have all of the elements put together, when we have everything set up, we can come back and we can just pick each element and do any changes and adjustments that we need. So this is just a very brief introduction to the Cryptomatte. Super, super handy. Again, I use this in all of the comps, literally all of the comps, because you will most likely always need to isolate certain parts of your render, and you always want as much flexibility as possible. We have a Cryptomatte on the environment as well. If I drop down a Cryptomatte node, we can see how the elements are separated here. So if I wanted to affect just the ground, I can select the ground, and this will create this alpha mesh for us, and we can do specific changes just for the ground. We could use this also to blend in our wispy smoke that's going across the ground. So from here, for example, if I were to drop down a blur node with B and I just blur this a little bit, this would probably be a fairly decent mask for our smoke, but it's probably better to just use the position or rather the world position in that case. But just to give you an example that you can really use this Cryptomatte layer in multiple scenarios. Now, one other thing that's missing here on this blade specifically, this is a very basic material that I set up in Houdini. It's really just a metallic surface with no detail on the surface, and I specifically set it up this way in order to show you a way in which we can add some of this detail ourselves directly in Nuke. So let's do that with the next lesson. I want to show you now a way in which we can add additional detail on our characters. So really on any part of our character, but especially this blade part, which has this very smooth material. We want to add a little bit of dust and scratches, and let's see how we can do that by just using a simple noise. So I want to introduce you to a new node, which is called STmap. And if we look closely, this will take in two inputs here, which is the STmap and the source. Now, really all this STmap is doing, it's going to map a texture to our UV coordinates, but really it doesn't have to be UV coordinates. It can be any kind of coordinates that go from 0 to 1 across the X and the Y value. So let me show you what I mean by this with a very simple example. If I were to drop down a ramp, and let's make this just a straight vertical ramp, I will just offset this first point over here so it's at the top. Let's do something like this, and let's duplicate this, and with our second ramp we want to make an horizontal ramp. So if I were to just make this real quick, I'm just going to adjust this ramp so it's nice and horizontal. Let's do something like this. It doesn't really have to be perfect, but now essentially we can use these as our coordinates. So if I were to plug the STmap, if I were to point this to our ramp, and as a source for now, let's just use a noise texture. So we will use the noise from this draw category over here. Again, it's the same noise pattern that we kept using. Let's point the source to our noise. And when we go to the STmap, let's now set the UV channels. This is the most important option. So the UV channels, let's set this to RGB. And now what happens is it's essentially going to look at the red and green values of this ramp. And this is how our noise will be mapped. But since our ramp only has values, so if we inspect our pixels here, we can see really that we just have this 0 to 1 value across our X dimension. And we also need it on the Y. So from our ramp, I will do a shuffle and I will disconnect everything except the red channel here. So I will disconnect the green and the blue. So now we just have, if we look at the pixel analyzer here, we just have a value that's going across the red channel that's going from 1 to 0 essentially. So now I want on the green channel to introduce our vertical ramp. So I will point this A layer here from the shuffle to our ramp. This is our vertical ramp that we created earlier. And in the shuffle node, let's set the input here to A. So our second row over here. And from the A layer, I will populate this with the RGB channels. And I will grab the red channel. We can grab any of these channels. It doesn't make a difference. But I will grab the red channel in this case, and I will place it in our green channel in our outputs. So we have successfully combined our ramps. We have a value that goes from 0 to 1 on the green channel vertically, and we have a value that goes 0 to 1 on horizontally on the red channel. And now when we go to our STmap, we have both the X and Y coordinates, and we can see that our noise is mapped properly. Now here, for the best results as well, it's better if we use a square texture. So this noise over here, let's drop down a reformat, and let's set this to a 2K texture, so square 2K. We'll point the noise to our reformat. So now we have this nice square texture, and it doesn't have to be a noise. We can, for this example, we could use a scratch texture, but just to keep things simple, we can use the noise. And I also want to show you the versatility of this noise layer. So now if we go back to our STmap, we have this noise mapped to our coordinates. And for example, if I want to grab this ramp, we can clearly see how this works. If I were to adjust this ramp, if I were to squeeze in this value a little bit, we can see now how this changes our STmap. So while I have this STmap previewed, let's go to our ramp and I can show you how our texture gets mapped or rather remapped in real time, and we can do the same with our our vertical ramp. Now as we do this, we can see that the texture is not really tiled, so it's a little bit different from a 3D app. Most 3D applications will tile the texture by default. There's ways that we can can kind of force this styling to occur, but I don't really want to get too advanced on this topic. This is just to demonstrate how this STmap basically works. So obviously, instead of just creating our STmap ourselves as we did over here, we usually bring over the information from our AOVs. So in this case, let's go ahead and get rid of this ramp thing over here, and we'll grab one of our shuffle nodes. Let's copy and paste this, and we will probably want the unpremulted version, so we can point this shuffle all the way here, and let's rewire this and bring this over down below. We'll do something like this. I think we went the long way around. We probably could have done something like this. So maybe this makes more sense. Again, this just points to the unpremulted version of our render. So from this shuffle now, we can bring in, this is going to be called this UV extra. So we can see again the same red and green kind of business. So if we use this as our STmap, again in our STmap, we can see now our noise being mapped over here. Just make sure that the UV channels are pointing to the RGB if in your UV extra. If this STmap was pointing directly to our render, we now have to set the UV channels to look for our layer specifically. So from the other layers here, we can choose UV extra to get the same kind of thing. But I think it's more intuitive and more in line with the way that we've worked so far if we were to point this to our shuffle and we use the RGB channels instead. Because essentially this shuffle outputs an RGB value. So this is why we have to set this here. Now, we have a little bit of a weird issue. We can see that in some places, like over here, the noise is working fine, but in some places it's stretched. And this is because really the UVs are messed up. If your model has proper UVs, you won't run into this problem. But in this case, the UV on the sword is not very great, and this is why we have this stretch thing. Now, we can kind of fix this a little bit if we modify this UV coordinates. So if I drop down a gray node, I will set this the channels here. I just want to work with our red channel, so I will deselect the green and blue. And now when we make modifications with this gray node, we will only affect the red channels, and this is easier to see if we preview directly from our STmap. So by adjusting the gamma on our red channels, we can see we might be able to sort of squeeze in the texture a little bit to sort of compensate for this stretchiness. And we can do the same thing with another gray node. I will set this to only work on our green channel, and we can again play around with the gamma, so we get so we kind of try to sort of skew the results in our favor. We can also play around with our black point and white point when we do this kind of modifications. We can see that at some point, if we mess things up, we end up with this problem where our texture gets stretched. So maybe in this case, we just want to mess around with the gamma. Now, because we are using a noise texture, we can also just go to our noise pattern here, and in the transform, we can go to the scale and we can split up the values in width and height in this case. So we can maybe lower the width, and we can see now that we can pretty much also fix it in this way as well. Now let's go back to our noise, and we can play around with the size. We can make this a little bit smaller. We can increase the gain and maybe decrease the gamma. Now it's worth just seeing this as our final result. Let's go ahead and try to merge this with our character. Now I'm gonna place this scratch detail over here after all of our combined shuffles. Technically, you should place it per each individual shuffle. So when you add a roughness texture, this would affect the specularity and the diffuse in different ways. So you would have to spend a little bit of extra time if you really want to get super specific. But if you want to just have something done fairly quickly, we can just place this after all of our combined shuffles. Now, if we were to do a merge from here over our entire character, this is obviously not what we want. And I will set this operation here. Let's set this to screen. So first of all, I want to limit this to just our blade, and we have our Cryptomatte. So we have the alpha mask from our Cryptomatte over here with just our blade, and on our merge node we can just specify this blade mask as our mask. So I'll grab the mask from over here and let's point this to our Cryptomatte. So this takes care of one part part of our problem, and the other part is we do want to integrate this texture slightly with our actual render. So a very easy way to do this if we just multiply our result from over here. So our final merged result of the shuffle, let's drop down a merge node on our STmap and we'll point the other layer to our merged result, and let's go ahead over here and set the operation to multiply. So now it's going to pick up the colors and the highlights from our render, and it will create for the most part a pretty smooth and seamless result. As we can see over here, if I were to bypass this multiply, this is the result that we get. So with just a few simple tricks and with our STmap, very easily we can create a nice layer of dust and scratches with a simple noise pattern. Obviously this might look better if we were to use an actual dust and scratches texture, which you can find plenty online, but I think it works fairly well with a noise as well. I really like to spam these noise textures throughout all of my comps usually. So if we preview the final result as well, this is with our dust. Now probably this is a little bit too much. We can always just gain things down. Let's add a gray node after the multiply here, and we can just maybe gain this down, make this not as obvious. We can still play around with the noise, but I think this is looking pretty fine as it is. So if I were to enable and disable this, very easily we can add this extra detail on our sword, especially since this is pretty close to the camera. We don't really want this very smooth material, kind of looks like a fake CG from the 70s. So this is just an example on how you can use the STmap in your workflow. Now really with this STmap you can push this in multiple different ways. You don't really just want to use this to add extra details on your renders. You can really do some crazy stuff, and we'll take a look at an example later as well. But for now, let's keep things as they are, and let's maybe start to organize our character setup here. I might want to actually, maybe we can hide this connection from our shuffle here with the UV extras. So I will press Alt H on this dot, and now we no longer see this. And we also, I might want to hide this connection as well, or try to make this at least a little bit cleaner. So this whole thing over here, let's do a backdrop, and this can be our scratches. Let's do scratches sword, and over here the rest of our nodes, maybe make some room. Everything else over here can be our, let's do backdrop, and this will be our beauty recreate or rebuild beauty. So we'll do rebuild beauty, and let's maybe make this darker. And now we can move forward with the next lesson. For the following lessons, we are going to be using some nodes, or rather gizmos, that aren't directly available with the Nuke installation. So these gizmos are created by the community, and we can find them on Nukepedia. So if we go over real quick on Nukepedia, this is it, and here we can see it says right here in the title, over 1000 free tools for Foundry's Nuke, which means that all of these gizmos that we can find here are free. So these are made by the community, and really this is one of the major strengths that Nuke has over maybe a similar compositing tool like Fusion, because some of these nodes are incredibly powerful. Some of these artists that contributed to Nukepedia really created some amazing gizmos, and I will encourage you to go on Nukepedia and check out some of these gizmos. You can check them by categories. We can see here, if we go to downloads, we can choose gizmos, and then we have a bunch of categories here. So most of these are actually really useful because they serve a specific requirement in compositing. So every gizmo that's created here is created essentially out of a necessity. So these are pretty much all of them are extremely useful, which brings us to the next subject here, which is that a few people put a bunch of these nodes together, all of the most useful gizmos from Nukepedia, they put them together, and this is where the Nuke Survival Toolkit comes into play. So this is a free tool that contains all of these free gizmos. When you install this, it will install all of these gizmos automatically, so you don't have to do anything manually, and it really contains a lot of powerful stuff. So over here where we have the toolkit documentation. We can take a look real quick and we can see in the menu over here there is all of our nodes laid out, and we also have some examples and a very short description on each of these nodes. And we can see that we really have a lot of gizmos, and all of these are extremely useful. So all you have to do really is go to this link, and here we also have an intro and installation video. So I will really recommend installing this. If you plan to do anything in Nuke, you will 100% need this toolkit. So with that being said, we are going to be using some of the nodes that or other gizmos that are available in this toolkit going forward with the next lesson. So go ahead and install this, and I will see you in the next lesson. And now with this lesson, it's finally time to talk about one of my favorite subjects and one of my favorite things to do in compositing, which is adding glow. Now, adding glow can be a fairly simple subject and an easy thing to do, but it can be pretty tricky to do properly and to get it right. So usually we want to add glow on emissive objects, and in our courses and in my work in general, this happens all the time because I always have a magical particle layer somewhere, and that's usually with an emissive material, so it's nice and bright, and it's usually the element which I want to focus on, so it's really a no-brainer to add glow to that layer. And in this case, on our original render here, on our read node, we have an emissive material on the eyes of the character specifically, and on the edge of our blade over here. And this is, we can access the emissive AOV for this specifically. So from our shuffles over here, there is an extra shuffle in the case for our character, which we didn't have in our environment render, which is the direct emission. So we want to bring in this shuffle over here, probably after our foreground smoke. So let's go ahead and instead of creating a big wiring from our render over here, we will use the PostageStamp node, which we used earlier. So let's drop down a PostageStamp. We'll grab our render, and in this case we are not really interested in the premulting or unpremulting in the case for glow, so we are just going to grab the render. Let's go ahead and shift select this PostageStamp, press Shift Y to create a forward connection, and then press Alt H to hide the wiring. So from here, this is essentially like a new read node, and let's drop down another shuffle, and we want to bring in, let's take a look, we want to bring in our direct emission. So we can see that this is going to be our emissive materials from our character, and technically to actually recreate the beauty pass, we will just have to merge this on top again as a plus operation. So to recreate what we had, we can do a plus over here, and now we also have this emissive AOV. And this is where we want to focus our glow on. Now, the naive approach will be to just add a glow. So this regular glow comes with Nuke by default. So this would be sort of like the default glow, and if we take a look here, we have some options, but let's maybe just increase the size so we can spread this. But we can see that obviously this doesn't really look all that great. If I were to enable and disable this, it's essentially we are just blurring the layer itself and plussing it on top. So this default glow is pretty trash. I will not really recommend you to use this under any circumstances. If I wanted to just spread out or blur out the image to create kind of like glints or something like that, I would just use a blur instead. So with that being said, let's go ahead and get rid of this, and we will use one of our glows from the survival toolkit. So make sure that you have installed the toolkit, and if I do tab, we can do AP glow. And if you've taken any of my other courses before, you will be more than familiar with this node, with this glow. This is a glow that I use all the time. It's my favorite exponential glow, and we can see already just with the default settings we get a really cool result. And if I were to just plus this on top as it is, we already have well, not exactly, but if I were to increase the intensity here, we can start to get some really cool results. The reason that this glow is better is because this is an exponential glow, and with the toolkit we have an exponent glow as well. So this is another another type of exponential glow made by somebody else, and this is also pretty good as well. Let's maybe increase the size over here, or let's increase the intensity and increase the size. And the difference between these nodes and the regular node is if I were to demonstrate this with a simple ramp, when we do our normal glow, it has this linear fade, but light in real life has an exponential decay to it. So really what we are interested in, if I add a gray node and I increase the gamma, this is the kind of decay that we want. So we don't want a linear decay, we want the objects to be super bright right around their surface, and as the light propagates through the scene, it starts to decay very abruptly. So we are kind of looking for an exponential ramp over here. So if I were to increase the gain, this is more or less what the AP glow will do for us, and this is why it looks so good and it looks a lot more natural. And again, I will really recommend that you refrain from using the standard Nuke glow, which again is really just a glorified blur that's plussed on top of the layer. Now if we wanted, we could just leave this as it is, and we can see that this looks pretty cool, and this would be sort of the more beginner approach. We could keep it as it is, but I want to show you some ways in which you can just add a little bit more detail, a little bit of layering to this, and how you can get more control and make this slightly more realistic. So let's go ahead and I will disconnect this from now. Let's maybe... And the first thing that I want to do is I want to separate the layers for the eyes and for the sword. So let's go ahead and from my shuffle, let's drop down a Cryptomatte, and let's point the Cryptomatte to our render. We'll select our sword, or actually we can see that we just have to select this sword glow over here. So I will get rid of the blade selection. So we just want this edge thing over here. And now from my shuffle, let's go ahead, and if I want, let's drop down a merge, and I want to introduce you to a new operation here, which is in. So if I set this operation to in and I point the B layer to our Cryptomatte, we can see that our RGB channels, this thing over here will look at our alpha from the Cryptomatte and it will sort of use it as a mask. So now when we look at our result, we just have the edge of our blade. And we can do the same thing for our... I'm just going to grab all of these nodes, press Alt-C to duplicate. Let's link them up to our render, and over here in our Cryptomatte, let's clear selection, and let's just grab our head in this case. So when we look at our merge here, we just have our eyes. So we have our sword over here and our eyes over here, and we can do some custom things for both of these when we add these back together. So if I drop down a merge and plus these both together, we have from here the same result that we had initially. So when we preview this from the glow, this is what we had. But now essentially I can go over here. So where our sword is, I can drop down a gray node, and if I drop down the gain, I can affect the overall glow of our sword without affecting the eyes as well. So now I can drop down a grade here for the eyes, and I can increase the gain. We can see that this direct emission layer is a little bit messed up in how I set it up, because it also brought a little bit of the helmet as well. This is to do with the material assignment is not really correct. So from our shuffle over here where we bring the direct emission, I will drop down a grade and I will just bring the gamma down. So we are just isolating our eyes and we can see the difference with and without. So now our let's go to our AP glow. We are ignoring the part of our helmet. So we have individual control now both for the eyes and the sword, which is great. Let's maybe go to our sword and increase the gain here slightly. But what I want to do is maybe break up the source for the emission for this sword. So meaning that before we run our AP glow on our sword over here, we might want to break this up with a noise texture. I usually want to avoid really large areas where we have this sort of flat color. Even though in reality it would work something like this, I kind of want to break it up. I want to add just a little bit of detail, and in this case we can either use the STmap technique that I've shown you earlier, but I think we can just get away by adding a noise layer. So let's drop down a noise over here and let's just simply multiply it with our sword. So I'll set the operation here to multiply, and we can see we have this very nice breakup in our, this affects also the color but also the intensity. So now when we go to our AP glow, we have this really nice variation in our glows. So you always want to think about ways in which you can break up your layer. So with this noise selected, I can reduce the size of the noise and maybe I can increase the gamma. We just want a little bit of this breakup, so I think this is looking fairly good. We can plus this whole thing on top of our comp. And another thing that I usually like to do with this kind of glow layer is I want the actual emissive object to be a fairly desaturated, close to white color. So when we add a glow on top, it will really feel like it's this super hot kind of thing. And let me show you what I mean by this. If from our plus operation over here, I were to drop down a saturation node, let's go ahead and I will set this all the way maybe to 0 or something like this. If I were to merge this with our AP glow and set the operation to plus, if we preview our final result, now this is what we get. And we can see that with this extra layer on top, we can really get more of a feeling of our emissive elements being super hot. And we can see this on the eyes as well. And if we now isolate our glow layer, it looks something like this. So again, this is fairly good. And one more thing that we can do here is we can break up the glow layer itself. So if we think about what would happen in real life is this, because we essentially have a really atmospheric and smoky scene, some of that smoke would break up our glow. So we want to replicate this breakup again with a simple noise pattern. We can just copy this noise that we already have. Let's paste this over here, and we want to multiply this over our AP glow result. So if we do this, let's set this to multiply, we see we get this really cool breakup in our glow. And this is again one of those things that will help us solidify our comp and actually add more depth and layering to our effects. I will also drop down a gray node here and I will push the gamma out. Maybe we don't want this to be as harsh. We want this fairly subtle thing. And for our noise, we can also animate this on the translate Y over here. We'll make this move. And here I will press equals to add an expression. Again, what we did earlier. Let's do frame and let's just leave this at frame and see if the speed is all right. Okay, maybe we can make this faster. Let's do frame multiplied with 2, maybe even more. Let's do multiplies 3. And we also want to go in the noise tab here and add some value on the Z channel here. So here we'll do frame multiply maybe 0.02 and let's see how this progresses. So something like this, I think it's fairly good. You could also, instead of this noise, you could also use one of these smoke elements to break up the glow. But in this case, it might work better with just a simple noise texture that's animated. So if we were to cache a few frames here just on this glow channel, we can take a look. All right, so okay, so I think this looks pretty good. And again, this is one of those subtle things that will help us really bring our shot and make it feel more alive. So if I were to preview this from our final result here, maybe I want to overall increase the glow here in the AP glow settings. Feel free to experiment with some of these values. We can make this more contrasty, or we can flatten this a little bit. Let's maybe increase the persistence, and this will be completely up to you. And also you can see here that the color is blue, and in the final render that you've seen, the color is orange. So we can very easily change this. If we were to go to our shuffle nodes over here, we can drop down a grade after the shuffle, and inside this gain here, we can just reduce the blue channel and increase the red slightly, maybe reduce the blue channel even more until we get exactly the color that we want. We might want to bring the red channel up, and we can see how very easily we can go from blue to orange. And this speed of iteration is again why Nuke is so powerful, and we can just pretty much copy and paste this node over here for our eyes as well. And for our eyes, for example, we can maybe push the reds even more. We can drop down overall the gain here for the eyes. and we can see the amount of control that we have. So I'm pretty happy with this. We can go ahead and call this glow layer done. So we can do a backdrop here as well, and we'll name this one, let's do glow, make this darker, desaturated, and maybe finally I will just maybe increase the intensity even more. We'll do something like this. We'll probably have to come back to this layer as well and readjusting, so it's not worth spending too much time now. Now this is really just the first part of setting up our glow layer, and in the next lesson we can take a look at the second part. So just adding the glow on the emissive objects is only one part of integrating the glow with the scene. The second part is we have to take into account what would happen in a real world scenario. So even in 3D, if we were to have this very bright, super emissive object in our scene, a lot of this light from this emissive material will spill over to the other parts of our render. In this case, we are mostly concerned about the character because our maybe a little bit would spill onto the ground as well, but the ground is pretty far from this tip of the blade, or rather the edge of the blade. So we are mostly concerned about some of this light reflecting and bouncing on our character as well. Now obviously this would be better done directly in 3D. Usually with the AOVs you can split up the direct emission. You can have the direct emission as a pass that isolates these emissive parts, and then you would have the indirect emission, so the contributions of that emissive material onto the other parts of the render. But in this case, let's say that we don't have this, and in fact we don't. So we want to add this global illumination or glow bounce ourselves, and we can do this by using the Relight node. So this is the next node that I want to show you. This is a super powerful node. It has the potential to completely alter a render and give you the most amount of flexibility. So we will place our glow bounce after our scratches for the sword over here. I'll grab these setups and I'll just drag these down below, and let's also drag down our viewer, and let's place down over here a Relight node. Now over here we are looking, this will populate with multiple different wirings in a second, but first we will have to specify the color, which is really this should point to our render, and then we'll have this lights, which we'll look in a second. So first of all, let's go with this color. We might want to just bring our render again over here with a PostageStamp. So let's drop down a PostageStamp. Let's bring our render before the Premult, and we will shift select the PostageStamp, Shift Y, and then Alt H to connect or rather hide the wire. So now this color can point to our render, and in the Relight, let's set some settings here. The normal vector should look at our normal pass, so I'll set this to N, and our point positions should point to our world position, which is this P layer. And now in our lights, if I were to add a light here, let's drop down a light and let's add this to our lights. In our Relight, we currently don't have anything, and I have the properties value here set to 2. Let's maybe set this back to 1. So we currently don't see anything, and now we can see that when we add the lights, we have a new arrow over here showing. If I drag this over, we can see that we are also now requiring a camera. So let's go to one of our camera nodes. Let's grab this one. It's the same camera that we kept using. Let's paste this over here and let's point the cam to our camera. And now we have one more arrow. This is now looking for a material. So if I do tab and type here material, we can apply a basic material. There's also a specular. There are multiple materials that you can use, but the basic material will do just fine. So let's point the material to our material, and now we can kind of see something. If I were to grab the light and I use the translate coordinates here to move this around, we can kind of see how this affects our character, which is super useful. So this works exactly how it would work in 3D. We can just move a light across our scene and it will affect all of the objects that we have in the scene. We have some other settings that we will look to in a second, but essentially now what we can do to preview this in 3D, we can grab another position to points node. Let's point this to our render, and if I were to preview this, let's set the surface point here, we'll set this to P, and our surface normal, let's also set this to N. So now we also bring in the normal information as well, and let's increase this number of properties that we can preview here to 5 because we are working with this 3D view. And essentially now if I wanted to merge multiple objects, multiple 3D objects in the same scene, we can use a scene node. Let's drop this here and I will point this to our position 2 points and the second one to our lights. And we can also bring in our camera as well if we wanted to. We can grab this and also bring in our camera, and now we can see that everything is merged. And this basically means that the light that we placed for our relight over here can interact with the objects in our scene. So if I grab the light, I can now just simply move this in 3D space and we can see how it affects our character. Let's grab the light. I'll place this down below. We will want this to be roughly where our sword is. So let's do something like this. I will set the fall off type here. Let's use quadratic, which is going to be this exponential decay that we talked about. So this will give you a more natural or rather more physically accurate result. And we can increase the intensity. We can see this over here. And now if we go to our relight and press tab, we can also see this, how it affects our character. Now we have a small problem here with our sword, but let's not worry about this for now. In our relight, we also want to turn on use alpha to get rid of some of this problem here with our edges. So it's kind of like the Premult version. And now with our light, let's maybe just reposition this. We can also play around with the translate direction over here directly. We might want to, I kind of want to skew this a little bit, even though it's not going to line up perfectly with our sword. I kind of don't really want to brighten up the character that much. I will want to move the light a little bit more around. And we are doing here some very creative choices. So you can see now that if I were to look to the 3D scene, our light is really all the way over here and our sword should be emitting light from over here. But this is again one of those advantages of doing this in compositing, that we can do these kind of offsets and sort of try to warp reality in our favor. So let's select back our light, and we can see that from here, if I were to bring the light where our sword is, this is more physically accurate, but this looks better, and it will still make it make our scene feel like this glow is integrated. We can also see what happens if I play around with the Y value. So I might bring this up. I might bring this, let's maybe lower the translate X, and maybe let's actually bring this further out. So so our character is not as bright, and we can do something like this. We still have to take the sword into account, but we'll worry about this later. Let's for now leave this as it is, and we'll bring this over here, and we want to merge this on top of what we have, and we'll set the operation here to plus. And now we can set the properties here to 1. So this is the result that we have, and if we preview this with the glow, we still need to color correct our relight node. So from over here we can drop down a grade, and we can first of all try to increase the contrast here. If I were to decrease the gamma, let's leave this as it is, because we still have to talk about the material a little bit. So in this basic material, we have a few options here. We can increase the diffuse, we can increase the specularity. So these are kind of self-explanatory. Feel free to play around and see if you get something that works for you. I will set the specular here roughly to 0, and I just want to use mostly the diffuse value here and not so much the specular. Maybe I can bring down the diffuse. We should probably preview this from our final result, and let's go back to our basic material here and maybe increase the diffuse a little bit. And now with our grade node, I can drop down the gamma. Let's do something like this, and we'll add another grade node which we will use to color correct. So I will split up our color wheel here. Let's increase the red channel and decrease the blue channel, so we have our orangey kind of look that we have on our blade. All right, so now this will fit with our blade, and we can see that with this bounce layer on top, now it should really feel like our glow is solidified in our comp. This is overall maybe too much. We can go back to our basic material and drop down the specularity a little bit. Let's go to our grade and maybe decrease the overall brightness. we want something just a little bit more subtle. But we can see even with something subtle, this all of these small detail and all of these levels add up to our final result. So you always want to think how the elements that you are adding, or rather the new elements that you are adding to your comp, you always want to think how these interact with the environment that you already have. So for example, if this character was standing on water or something, we would have some puddles on the ground. We would have to think about how these elements interact with those puddles. So we will need to fake some reflections and maybe refractions as well. And all of these are things that you pick up along the way as you are doing more and more compositing. Now with our Relight, we are completely ignoring the sword, and to kind of fake a little bit of this bounce on our sword as well, we can just bring our character render from over here. So after our Premult, let's go ahead and from this Premult, let's bring a Cryptomatte on our render to isolate the sword, and we'll control click the sword, and now we can do a merge between this Cryptomatte and our render over here. Let's do A to B so we can use the in operation, and we are just going to mask our sword with this Cryptomatte. Let's also drop down a saturation and make this completely black and white, and then we can just merge this with our Relight over here and set the operation to plus. So now let's take a look at our grade node and our other grade. So if we look at our final result, we also have a little bit of bounce lighting on our sword. We can still drop down a grade node after the saturation here, and maybe I want to increase this gain here, and this will be up to you to decide how much you want some of this bounce on the sword specifically. And let's take a look one more time. I'm pretty happy with this result, and we can leave this as it is for now. Let's maybe drop down another dot over here, and we'll do a backdrop. So this will be our bounce. Let's call this glow bounce lighting, but let's just leave this as a glow bounce. Let's set this to a darker color. Now this bounce affects our character, but really it should affect the smoke as well, especially since this is a very thin kind of smoke. The light would naturally propagate quite a lot through this thin layer of smoke, and let's look for our foreground smoke over here, and this will be a little bit more simple. We'll just do this with a simple radial. So if I were, let's maybe just make some room over here, I can drop down a radial which I can place over here across our smoke. So this radial is just a simple circular mask with fading. Let's also drop down a blur node with B, and I will increase the size here to kind of blur this out a lot more. And we can simply use a grade node, and let's point this to our radial here, so the mask. And with this grade node, I can now go to the gain here and just make this more orangey around this masked area of our smoke. And now if I were to preview the result, we also have this nice light interaction with our smoke, and we should probably make this a little bit brighter as well. So you can either adjust the gain or the multiply. The gain and the multiply are essentially exactly the same things. So with this multiply on the same grade node, I can just increase the overall brightness of our colors. So let's take a look, and I'm pretty happy with this result. And one final thing that I want to add with our glow, with all of the glow layers and the glow bounce, I want to add a slight flicker to this glow just to introduce even more life to our scene and have this very subtle thing that's not really going to be obvious, but it's something that we can sort of feel. And let's go to our glow over here, and what I want to do is drop down a grade node, and maybe I'll make some more room. I will use this grade node, and I will set this gain all the way. Let's set this to 0. Let's do maybe 0.5, and now I can use this mix value essentially as the strength of this grade node. We can see that if this was 0, this lower gain value will not be taken into account, and as I increase this, we kind of we essentially increase the strength of this gain setting over here. So we can see that as I play around with this mix value, we kind of create the flickering that I'm after. So instead of setting keyframes on this mix, let's go ahead and right click and set or rather add expression here. So in our noise layers, we use the frame value to help us create an expression, and another value that we can use here will be random. So if we type here random, in between parentheses we will have to specify. We can see that if I just leave this as it is, it will already output for us a result, but we will want this random number to change for each frame. So in between parentheses as an argument we will type here frame, and now if I hit OK, we can take a look. We haven't explored the curve editor or the dope sheet yet, but if I were to look in the curve editor, we can see that it creates this value essentially that goes from, let's maybe see if I can zoom in here. I will hold Alt and middle mouse drag to the right to see exactly what's happening. So each frame we will get a random value between 0 and 1, and as a result this will now create the flickering for us. If I were to just zoom in on our timeline real quick and let's play the animation, we can kind of see this flickering that happens. Alright, so if we want to reduce the frequency of this flicker, we will just have to divide our frame number. So if I go back over to the expression, so again I will just highlight the value and press equals. In between parentheses over here I can do frame. If I want to lower the frequency by half, I can just divide this value by 2. So when I do this, we can see that our curve is a little bit more spread out, and this will mean that our flicker is a little bit less intense. And maybe this is what we want. We might want to reduce this even further. Let's do divided by 3, and now we can see we have kind of like a more smoother curve. And let's play the animation. All right, so I'm pretty happy with this, but now since our glow intensity changes, this will affect our bounce as well. So we want to use the same kind of grading adjustment on our other layers too. Now we can just clone this grade node. If I press Alt K, this isn't obvious right away, but if I press Alt E, and this might be turned on by default for you, we can see with Alt E this shows all of the nodes that are linked together, whether through cloning or expressions. But now we are connecting these two gray nodes. So if I do any adjustment on either of these gray nodes, if I were to set the gamma here to a lower value, we can see on this node it changes, but on this node it changed as well. So it's really helpful, especially in this case. Let's set this back to 1. Let's go ahead and link this gray node. Let's link this to our glow bounce over here. So let's do our grading adjustment. So this is basically the intensity. We will place this after our first grade node. I can even maybe rename this, let's do flicker. So we can add a label to any of these nodes in order to stay more organized. So now our glow bounce will also have the same flicker that we have on our main glow layer. So we can see this now over here. So now that we have this glow layer, we pretty much have all of the layers that we need. And with the next lesson, we can go all the way back to the top to the environment, and we can start making some small changes. We can readjust our grade nodes and see where in between all of these layers we can maybe add a few extra details and really fine-tune the overall look of our comp. So I will see you there. So now that we have all the layers that we need, it's simply just a matter of going back and adjusting everything, and now we can take a look into some of these finishing touches that we can add to make everything come together. Now, if we go back to our environment all the way over here, after we do our premult, one more thing that I want to add on this environment, I want to show you one of the nodes from the Nuke Survival Toolkit installation, which is P-Noise Advanced. So if we type here, let's type noise, and this is the one that we want to use, P-Noise Advanced. Again, you will have to install the Nuke Survival Toolkit to access this node. Let's point the image over here to our, we can point this to the unpremulted version, so we can point this to our render from over here, and with this P-Noise Advanced, we can specify the world position pass, and similarly to how an STmap will work by using the coordinate system on the X and Y direction or the red and green channels, this noise gizmo will use the red, green and blue channels to map a noise texture over our world position. So if the position data here, I will set this to P, we can see now that we have this very cool noise texture running across our geometry. And of course, this will follow the camera, so it will stick to the geometry. So you can either use the UV, AOV to map certain types of effects, but you can also use the world position. So that's something to keep in mind. Now over here, we might want to make this noise slightly bigger. I might want to play around with the increase the gain here. And let's go ahead and just multiply this over our result. And let's do this after or rather before our premult. So I'll drop down a merge and set the operation here to multiply. And this is what we get. So we can see that we might want to bring up the size of this noise. Let's increase the gamma. We can drop down a grade node and we can increase the gamma in this way. Let's preview with 5. I will set up the final result here. So I will preview this on 5 and we can see that with our extra layer, so we are not really getting the result that we are after. So we are not getting the correct result, and this is because we are modifying the alpha as well, so we don't want to break up the alpha. So with that in mind, let's actually do our P noise advance before we copy the alpha. So we'll drop the merge over here before our copy and our premult. Let's drag these over maybe to the side and let's do our pre-multiplication over here. So now we finally get the correct result, and we can go back to our grade and let's increase the gamma maybe, or we can play around with the gain. So with this, we just add another extra layer to break up our textures. We can see that this really adds a lot of layering and detail to our environment, and it was super simple to set up. It's essentially we are just mapping a grunge texture over our entire environment. Now again, this is one of those things that you are better off doing directly inside of render, but even if I had this in render, I still occasionally like to use this noise to break up the textures even more. And I think especially for a scene like this, it provides an amazing result. Let's go ahead, maybe I'll just bump up the gamma slightly so it's not as harsh, and we can now go back to some of our other grade nodes. Let's take a look at some of these. Let's see what are the biggest contributors over here. So I might want to lower the reflection of the sky. Let's look one by one. I might want to lower this down even more. Our sun pass. Let's take a look at our other one. All right, maybe I can bump this one up slightly. Preview the final result. Maybe this is too much. Let's bring some of this back. So I'm not gonna spend too much time really trying to finesse all of these values. I will leave this up to you because this process is pretty self-explanatory. I'm just trying to find the right values here. I might want to lower the amount, or rather the thickness of some of these smoke cards. Let's go over here and see which of these needs adjustment. I will drop down the alpha for some of these smoke layers to make them more transparent, and I can make them less bright as well. Let's do something like this. One really cool thing that we can do, especially with foggy scenes like this, and let's take a look at our fog setup as well. I might want to overall lower this even more. I might want to drop down the gain slightly. We can still play around with the grade here that controls how far we are spreading our mask. We can maybe lower this value, or actually I think this should be fine. Now one thing that we can do after we add our sky and our fog, so from over here we can add a bit of diffusion. So if I were to drop down a blur node with B, let's maybe just drop down another dot over here with period, and let's connect the blur to this dot. So what I want to do here is just blur this image out. Maybe let's do something like 300. And now if I merge this on top of the actual result, I can set the mix value to a very low value, and we can see it creates this very nice diffusion, and it kind of helps us to blend all of our elements together, and it adds sort of an extra fill layer. In this case, since this is a very atmospheric, very smoky kind of environment, it kind of helps to bump up that feeling of smoke. So if I were to turn this on and off, we can see what this extra blur layer will do for us. Now we don't really want to exaggerate, and we can still play around with the size of our blur. Maybe we don't need this one such with such a high spread. I will leave this value at 100. And let's go back and inspect our merge. So we can see with this extra layer, this really helps to blend a little bit of these edges and the buildings with our sky element in the back, which is really cool. So really helpful, especially if we preview this with our final result. This will introduce even more contrast with our foreground, which is our character, and the background. So a super quick and easy but extremely powerful technique. And furthermore, I will want to introduce maybe even more of this blurriness, but I want to isolate it with this area here, which is essentially the building that's furthest away from our character. So we want to do the same thing. I'll add another blur node, but we want to only affect this area over here. So I will create a radial, and let's place this roughly where we want it, around this place. I will go to the first frame of our animation, which is 1001. I'll bring this all the way over here. I will right click over here to set a key on all of these values, which are the coordinates of this radial, and I will go to the ending of my timeline at 1240, and I'll grab the gizmo over here, and while holding down shift, I will just drag this over until it lines up with the furthest building away from our comp. And now we can see that for the most part this will track our building. Let's inspect some other frames as well. So I think this works fairly well. So now from our blur node over here, let's increase the size. Let's do something like this, and we'll do a merge, and let's set this B layer to be our radial, and the operation now, if we choose in, this will now be masked by our radial. But over here we might want to drop down another blur node so we can blur out the edges even more. Let's preview some other frames. We will probably have to expand this radial. Let's maybe go to our first keyframe here and just make this overall a little bit bigger like this. Go to the end on 1240 over here, and also increase the size here. And maybe I can decrease the blurring so we can see clearly what's happening here. So now I can merge this other new blur layer on top. We can see that we are just isolating the blur over here, and we can drop the mix value. So now the further away we go from our camera, the more of this blurriness kind of camera diffusion we will get. And again, we can just play around with the size of our radial. Maybe I still want to decrease this even more, like so, and let's go to the beginning of the timeline and also maybe adjust this over here. And if I go in between, we can see that this kind of tracks for the most part, and this is mostly because we have a very linear camera animation on the orbiting axis. So if we preview this from our final result with our character, again I can press Q to hide our handles on the screen. We can see with this extra layer we introduce even more separation in our background and more separation with the character itself, which is really cool. So here we can let's maybe hold down Control and place all of our layers up, and we'll do a backdrop over here. So this can be a little bit of we can call this here diffusion. So this blurring will help us separate our character, but another thing that we can do to create the separation is also introduce a little bit of color variation. So I can drop down a ramp in this case, and let's hit Q again. I will make this fade from the top, and I will add a gray node and point the mask to our radial. And with this gray node, I just want to introduce a little bit of blue over here, just so we break up a little bit of this black and whiteness that goes across our entire environment. So in our gate node, let's just decrease the red channel and increase the blue slightly. And if this is too much, I will play around with the mix value to maybe lower this. And I really just want to affect mostly the back part of our environment and the sky. So if I were to preview the final result, this is what we get with our adjustment. And this is a pretty nice contrast. I'm specifically doing this to make our orange color pop a little bit more We really don't have to go to very extreme values over here. Something fairly subtle, again, just to help our oranges pop out more and to break up the desaturated nature of our environment. So something like this will help us. We can take a look more into some of our other layers. Let's check out our ground smoke. I think this is looking pretty good. We can go forward with our character. I might want for the character, I might want to play around with some of our AOVs here. We can see that I'm just turning them on and off. We can see that this one is a big contributor to our shot, and this last layer as well. I might want to reduce the brightness overall of our reflection from the sky, and I might want to increase the reflection here from the side. And I think overall our glow bounce is too strong. I might want to lower this to something like this. And maybe I want to introduce more red in our overall glow. Let's look at we can go to the sword, which is over here on the left, and with our gray node, let's maybe reduce the green channel to get more of this red. And let's take a look at some other frames. All right, so I'm pretty happy with this. Obviously, the more time you spend, the better the final result will be. But these are essentially the techniques that you can use to make any adjustment that you want. Now that we have everything set up, we can go one by one and affect every pass, every light contribution, all of the layers that we created. And we really have the ultimate control this way. And finally, to finish up the comp, we can add some final post-processing effects. And some of these layers that I usually add is, of course, we can add a grain. So we will drop down a grain node, and here for the presets I like to use the last one, which is a bit more subtle, and we can see that this will break up that perfect CG look. It will kind of help us to replicate what happens in an actual camera. Now, depending on what kind of render you are working on, you might need to adjust the overall strength of this grain, so you can play around. I can maybe drop the intensity on all of the RGB channels here. This is more of an aesthetic choice, adding grain, but usually with a lot of CG renders you do want to add this grain because it also helps to bump up the blacks a little bit, and it will just help us smooth all of our layers together. So speaking of smoothing all of our layers together, we can add a final diffusion before our grain rather. So I can just add a blur node on our main chain over here. We can increase the size, and I can just drop the mix value over here, and we can see what kind of effect this will have. For our final diffusion, we do want to have the strength rather low, and with this final diffusion, this will help us to spread our glow layers, especially. It will help them be more spread overall, and again, it just helps to blend everything together. Let's look at this with our grain. Now, there's really a lot of different effects that you can use. You can do something that's called an RGB split. There's also halation, but we can keep things simple. We can just add a little bit of diffusion and our grain. And finally, from the Nuke survival toolkit, there's also a AP vignette node, which is really cool, which essentially just fades the corners of our comp. Again, we're trying to imitate what happens with a real physical camera, but in this case, it also helps us focus our eye more around this bright part of our character. Now, probably this is too much. I can just lower the amount a little bit, and the AP vignette is just something that I usually like to use in my comps. And now finally, to make this more cinematic, we can drop down a crop and we can change the aspect ratio here. Let's do 235 by 1. So now we have this classic film black borders on our comp. And from here, really, we can call this comp finished. And with the next lesson, we can do a final overview on everything we've learned so far. So hopefully you will join me in our final lesson. As our last lesson, let's do one final rundown over the entire comp, and we can start all the way over here with our environment. In fact, we can probably also do a backdrop here, and we can rename this to Rebuild Beauty ENV for environment. Let's maybe change the color as well. We'll do something like this. All right, so we bring in our environment render, we split this up per individual AOV so we can rebuild the beauty and have access to all of the individual contributions that make up our render. And then we add an additional layer of detailing with this P-Noise Advanced Gizmo that we've got from the Nuke Survival Toolkit. Moving forward to the right, we have our sky, which is just a texture that we added on a 3D sphere. And then with our camera, we can render this so it matches the alignment with our render. Just a simple gray node to darken this slightly. So this will be the background for our environment. With our depth pass over here, we created a fog layer, which we can add on top of our environment. We have some diffusion by simply using a blurred version of the same image and plussing that on top. Over here with this ramp, we just made everything blue on the top part of our comp. Then with 3D cards, we can add some patches or layers of smoke, which we can integrate in our render. We can mask them by the same depth map that we use to create our fog. And here we have our second one and our third one, nicely integrated with our environment, with our 3D objects by using the depth map. On top of this, we add a ground smoke, which we created with the noise that comes with Nuke, which is simply animated and evolved by using expressions. And this smoke is as well masked with, in this case, the world position. We grab the Y value of this world position. We place this in the alpha and we can do some grading adjustments and use this as a mask in our smoke layer, and this will be as well nicely integrated with our render. Moving down below, we have the beauty rebuild of our character. We've looked into how to use the Cryptomattes to make specific grade changes to specific objects or materials in our render. On top of this, we added scratches to our sword by using the STmap that uses a noise texture and the UV pass of our render to create this extra layer of dust on top of our sword. Then we have our glow bounce by using the Relight node, which is leveraging the normal pass and the position pass of our render with a light, a camera, and a material to create this nice bounce lighting that we get from our glow. So if we move forward, we have our foreground smoke and then finally our glow, where we use the AP glow, which is an exponential glow that comes with the Nuke Survival Toolkit, and it's probably my favorite node from really all of the nodes that are available with Nuke. Then finally, some very small camera diffusion with blur, AP vignette, and a gray node as our final post-processing effects to complete our render, and then a crop to just give this that cinematic aspect ratio. So this is all I wanted to cover, and with this we can conclude intro to Nuke. Well done on making it this far. Some of these topics may go maybe slightly above a beginner level, I would say, but I do want you to have a sense of what Nuke is used for in production. So all of this that was covered is really just scratching the surface of what Nuke is capable of. We can see that even though we have quite a big chain over here, this might seem big to you if you are new to Nuke or if you've never used it before, but really on a large scale production, something like this would be just maybe 10% of the entire comp. Some of these scripts are really insanely huge, and again, we are really just scratching the surface. But this is it for now. Thank you for watching so far, and I hope you enjoyed this course. If you want to learn more about Nuke, you can check out some of our other free courses or paid one as well. Usually the renders are included, so you can jump straight into compositing without having to go through the 3D or Houdini part. So go ahead and check out voxsite.com for more courses, and hopefully we will see each other again in a new course.